PhD when I was but she's no, she's working since my department. No, not. But she's going. He came here, so I mean, it would be fair. No, but that's how I think it's better to go to her.
Yeah. Much more.
The culture is close.
Yeah, exactly. The language and everything.
I hope that my English will be not so bad when we
Come back?
Yes,
I don't
because
think so.
I will don't speak. No,
I think you will.
Yeah, because I think that there will be like international students.
Yes.
When I went to Spain,
And this
I
Italian.
learned English.
Because
I spoke with the English.
I know that in this department there are now Italian people so English. I don't know. They usually speak Spanish too.
yeah, the professor say, the Italian people speak very well.
Boli tu na matematice majú také vysačky, čo majú ako takú umelú hmotnú. Na tej spojujete s tou polovnickou miestnosťou, či laveťkou, ktorý to je taký pekný stolík. Teraz dali CESCG.
Maybe, but not.
I don't know, like
Oni tu budú sedieť na klávese, aby si to pekne urobili.
Dobre.
Dobrý nápad, ne? A to je to, čo nemyslí. Má takýto veľký televízor, celý nábyt. Náš teraz sú zase proste zelené televízory.
no te pones bloqueado.
Big enough for the summer maybe.
To stojí 10 €.
It's funny because the professor Santiago told me that the people that have more cancer is in the north of because they are very yes, and when the sun comes, all of them are in the taking.
A do tej malej zasadačky
Idete?
Si sami ako chatka.
No však na to som hovoril, že poďme do tej chodbičky, tam je streka.
Tak okay, vlastne. Aspoň sa rozlučíme.
Dovidenia.
Dobrý?
Skoro sme.
Vás nechodí.
Áno.
A počúvajte, a out treba zrobiť, ne? Nie, ale výkonný títo. My sa dielame na
Každý svoj postup si dáva dole, ne?
No ja neviem. Ja som videla tam obaly, že som prázdne odpal.
Čo sa ľudia stavajú? Poď sa stavať.
Vymyslela som ľúky na
Vieš, že na teba nikto nechodí, že ty si dávaš poster? No tak, vystavi sa.
Ja by som nevedel používať, keby odešli, keby mosty, ale neviem, kde je natáva. Je to nám odmluvito. To treba priviazať.
No, čo?
Keby bol šnúrka, tak otvoriť to okno a privrznúť to do toho okna.
No, to je dobrý nápad.
Inžinierská mysl.
Nevadí, necháme zatiaľ to.
Mám mobil a na ňom to bude asi.
Pošarujeme jeden. To streamuje už, áno.
Však ale ten stream ešte.
Ale práve, že teraz, keď sme prechádzali, tak sme boli.
Ha?
No to sa jedná.
I'm gonna get something from my room.
Okay, see you. See you. No, tak.
Whatever drinks they want, tell at the ceremony, whatever drinks they want, they can buy them out in the bar. So,
Stream still on?
yeah. You're not so live.
Oh, cool.
One, two, three, four, one.
So, aber das nächsten Slide finde ich ganz normal mit der Maus. Also.
Eins, zwei. Eins, zwei, drei, vier.
Jetzt?
Nicht wirklich.
Oh, schlecht.
Eins, zwei. Eins, zwei. there's the camera.
So people could give feedback via Discord, right?
People on foot?
No, they can give feedback.
No, not a Discord. I would say directly a YouTube channel.
Ah.
They can comment on the YouTube channel. I need the second microphone.
Alle som dating. Oh, sorry.
Do we have keys?
Yes. Which one? Give us
I think 33. I hope so. Jan Lansko. Maybe right. 33.
Right now I'm into sneezing. I don't know. Do they also have sound, or are we just being silly?
I think the microphone doesn't work yet.
Okay. At least there's no sound.
Isn't that good? You're coming here and in the first weeks you already attend a real conference. Isn't that nice? Not only attend, I would say. Responsible.
Is the opening going to be here?
Yes.
Great.
But the microphone, somehow the audio is not working yet, so Martin is trying to fix that. And actually people could already be watching. So you could say hi.
Okay, I see. This is already one step better than Eurographics because, and Eurographics they didn't have this live feed, so if you were a virtual attendee, you could watch the videos, right?
No, you could also watch them live.
Did you?
Sure. I mean, this was live streamed and then you could watch it. They already distributed the links via email. Each
Well, I didn't check out those links, but yeah.
It was just a live stream, and like it was always at Eurographics. Like at the virtual events was more or less the same.
Okay.
But not so many people did that. I think there was just less than 100 online attendees. More than 300
Yeah,
were present.
I can understand that.
So it was still nice to, I mean, if you have missed something, you can still watch it afterwards. I think that's something that we should continue doing.
Oh, yeah. Well, you cannot watch everything with the parallel sessions. So yeah, there are definitely few I would like to catch up on, but I don't know when exactly.
But then, yeah, there's the problem. You don't really have time to catch up on it.
Always the problem.
That's the problem. So a little bit behind schedule now. We should speed up.
Actually, it's not needed anymore because we don't have that book. Yesterday. I think someone placed. Yeah, he wants to, so 22 belongs to someone called Corner.
Daniel? Ah, yeah.
And then David Hahn, yes.
But David is coming. Daniel, is he coming today? Or?
It looks like it, yeah.
This is not here.
Maybe in the afternoon.
No.
So room number 30 belongs to someone called Tavaga. I think they have them. So
Step in the sun.
Relax.
Martin. Another Martin. Martin Tavaga. So he has room number.
No, you're in full view because it's apparently recording with this.
Now, I have to share the keynote. I share his name right.
Only that guy.
štúdiový.
Čože?
To je štúdiový mikrofón.
No, aký máš konektor, vieš?
USB.
Nie, a tam máš USB redukciu. Tam máš originálny konektor.
Ja takto, počkaj, no to je pravda, vidíš? Takže si to došlo z neho. Ale to čo na to bič? Ráno sme hľadali oný USB-čkový kábel do tlačiarne.
Aha, to je takéto? Fúha, s tým nič nespravím.
Zaujímavé, že toto môže byť položené na stole a si nimi okolo koľka.
Skúsme na to, že chcem do YouTube streamovať, ale tým pádom ja sa nemám ako dostať na napichnúť. Či to majú.
Čiže osobitne nahrávať ešte na to, že budeme rozprávať. Toto teoreticky tu nemusí byť, odrazu to nikto nebude pľuť.
To znamená, že by som mal vlastne, on ide hej, dobre.
Nie, tam oni osobitne potom prihodiť len zvuk, audio. Áno, to je on. Raz, dva. No, tam ešte potom otázka, že ako bude vybudený, ako silno to vníma.
Ja si myslím, že áno.
Raz, dva.
Zapneme. Yeah. 1, 2, 3, can you hear us? Perfect. If someone is watching the stream, we have a little bit of delay. I think that we will start in something like 10 minutes, so 1/4. That would mean that we are half an hour delayed in total. So please stay with us.
Don't leave the castle, please.
Anyone has experience with OBS Studio here? With streaming OBS Studio? No one? Okay.
Tam by mal byť vyslovene, že filtre.
No, ale v tých som to nevidel.
Ja som nerezovaný.
Tu sú filtre, ne?
Áno. Expanduje? Možno? Nevyzerá úplne ako Zoom. Is it more for coding or more for art?
It's kind of split, but I would say I should more art because
Áno, vlastne, že kropnúť sa to a potom...
Yeah, it's difficult to find students who can do both. Yes, it is. So,
Bude sa to priamo premietať. No, nechoď to v stovkách pixelov.
Very hard combination.
We had a collaboration with because they had students who do that, and we had students who want to develop some game but didn't really have ideas. So we started some collaboration, but they had the idea, and we basically
začne len na pozícii
because this university was taken over by the government. They just put their own people there, and then all the teachers they left, and all the students they left. So this entire course is not great.
Yeah, I know. That is sad. Thank you. You know, this is a competition that people actually so our knowledge. So if they remove this, they cannot send somebody from places you to go.
Send them the same
I
level.
think you would do, maybe he'll do something else, but not those things. So one of those the same grades. So yeah,
Dobrý
they
den.
are still managing their same
No, právě
they're
teraz.
balancing that. I see it from exactly what you said. I told them on the start it could be, but you can really occupy it doesn't go.
I really want to have like quite conference, attend all the lectures and not to like just run
You know,
alone.
we had kind of two courses like one for engine program, all
I
these
have
things like
like
that,
one,
and the other
my
one was
first
in
like 6 now,
some collaboration with
but I have
me.
been
So maybe
like
something like you
one
mentioned,
like
having
at the
people
university,
calling that
I was teaching more courses and
more natural coaching and
doing some
Education organization point of view,
right now.
it's quite difficult because then people rely on each other to finish their thesis. That's a bad thing. What if one of them doesn't do it and the other side is
that's true, but that's true that usually, for example, are more okay, directing, camera, like theater, always things rely on. One has to like speak like one like the one has to so and it works kind of when you push it out, but it works. So in all the mix, it's really
teams are within the institute and on the
Můžu, až budete mít možnost technicky jenom já vám prezentovat první a zkuste se mé prezentace běžet tak jak...
No, teraz asi už mělo, už to bude, ale to bude nějaká výstavka.
Ok, já bych to tam jenom rád dal, jestli mi to spustí video, jestli mi to spustí PDF, to je všechno, a jenom abych náhodou neřešil, že nemám co prezentovat. Děkuju moc.
Spanish guys and the Estonians and the Bulgarians and Cyprus and all that. And that one is about technology and education. It includes VR, games, and education.
But then I also discussed it more with the programming guys, so they came up with the idea together. I explained what I need, and they came up with this. When we have cameras, they make algorithms for it to turn back. You know, if I turn the camera on the picture, the camera is always keeping it back, so that the user can actually decide. Because as you will see here, what we saw, the camera is moving around, and you're watching beyond film. It's something. It's a good place for collaboration between
nejak herdovať ľudí sem už.
Ešte není Maťo, neviem.
Lebo Maťo sa tváril, že za 5 minút sa začína.
Jednu vec zistím.
People I've crossed are here.
Okay, thank you. Neviem. Is there some data about what room I have?
Yes, give me a second. So, what's your name?
Martin Chavada. I'm the one whose name you couldn't find. Thank you.
How are you?
I know where I was several times.
Do you know where it is actually?
It's near the entrance to
Where is that? Okay.
there is on the left of the entrance. And you find some
Okay.
Yes, we will be coming in June.
no corners. Oh, yes.
Here to this conference, but on the last minute it changed her mother.
Also, because of the
No, there's just
I mean, life, age.
I really don't know.
So, no, it's our NGO where some guys are working.
Dann nehmen wir nur auf. Und das ist die wirkliche Erkennung. Dann nicht. Na, wie fast vor du jetzt aufgekommen.
I'm Dominik. I finished my thesis on improvements in probe placement in dynamic diffuse global illumination. We have implemented the original work by Roháček and evaluated its usage in architectural visualization. We have explored its pros and cons and presented improvements to avoid its artifacts. If you want more know about our improvements and how we dealt with those artifacts, come to my talk or see my paper.
I'm Michal Hvězda from Czech Technical University in Prague. In my paper, I evaluated a real-time global illumination algorithm called Dynamic Diffuse Global Illumination in terms of performance and quality of the final image. I detail my implementation of the algorithm and how it leverages modern ray trace GPU hardware to compute diffuse light transfer for a given scene. If you would like to know more on how to implement such algorithm and see results of my evaluation, come to my talk. I'm looking forward to seeing you there.
Hello, I'm Wojtěch from the Czech Technical University in Prague. My goal was to create
So this one is for recording of the stream. This one is for the speaker.
So both are it's about time to start, and I'm seeing myself now on the screen, and you can switch that over to something. So hello, yeah, and hello you guys, I see you, we have met and so on, but hello guys at home, or wherever you are, in the bathroom or whatever. If you like what you see, then just give us a few comments on YouTube, we'll check that out later on. So, it is the time. After 2 years of pause, after 2 years of not being able to come here, we are finally back. Or most of you probably are here for the very first time. And actually, most of you will be here for the very first time for an event like this, for a conference. You have now had 2 years of sitting at home and watching lectures by Zoom or by YouTube and so on, and doing other stuff at the same time, and maybe sometimes listening, maybe sometimes not. Now I see whether you're listening. And the presenters will see that, but of course I don't need to say that because there will be so many interesting talks and everything will be so gripping, and that will be, you cannot just do anything else. Yes, so that's what we're here for. So, welcome to CESCG. Let me see, what can I tell you today about this beautiful event. So CESCG, why do we call it CESCG? Well, I don't actually know. Maybe this is just the Austrian way of, when you see these letters, I think it's some kind of Eastern thing, then we say CESCG, it always has some ch, so we say CESCG. So it's the Central European Seminar on Computer Graphics. That is something that started out many years ago. I think if I recall correctly, in 1997, there was the first mutual event, as I've been telling some of you already, between Andre Verko and at the time Helge Krause, right? The two of them, I think they invented this over a beer, right? And they said, yeah, let's do that. Oh, this is dangerous, don't fall off the wall. And decided to have a seminar where the first day the Austrian students went to Bratislava in a lecture room and heard some talks, and then the next day everybody went to Vienna and went to a lecture room, heard some talks, and from then on we gathered more people, more partners from all around this kind of hub in Vienna and Bratislava. So we accumulated more and more people and went to castle. First was Wimmer Castle, which was a really nice old castle. Unfortunately, it was kind of, I don't know, went up in the politics somehow, or absence of politics, this is good politics. And but then we found this place, and we love it here, and I hope you will love it too. So, my name is Michaela Wimmer. I'm from TU Wien, from the Institute of Visual Computing and Human-Centered Technology. I've participated in the CESCG since the very first CESCG, and I just looked it up. I have been more or less responsible for this since 2005, when Helge approached me and said, so I need to do other things now, and maybe you can do this. And I said, well, yes, why not, for 1 or 2 years, no problem. Now here I am. Yes, so this was but actually being responsible, you know, what does it mean to be responsible? You watch Martin do everything. So Martin is there, it's everything, but actually Martin is doing the stuff, and it's just, if something doesn't work, you can blame me. But I will just go to Martin and say, sorry, somebody this is not working. So for many years now, Martin, who was also a student here and has been with us also for many years, has taken on the very practical responsibility of almost all the organization. And we're really very thankful for him. And the reason you're here is Martin, because he said, well, let's meet here and let's do this. Let's ask people whether they would like to come. I was a bit skeptical in the beginning, and now I'm really thankful that Martin was stubborn enough to convince me and to convince everybody to do it. And that's the reason why he is. I think he deserves a big hand. Give him a big round of applause. I can already bestow Martin the title of
Czech. That's really what it is. Okay, a couple of years ago we tried to balance the load a bit between TU Wien and Comenius, so we added TU Graz to handle kind of the scientific programs, all the reviewing and so on, and I'll tell you more about that in a second. So, what is Czech actually? It started out as a seminar. Over the years, additional elements were added, like an academy and like an expo. So the expo this year, we were brave enough to take this on. The expo was an event where we had many local and not so local companies showing their results and also giving the opportunity to look at how this company is working and maybe see future employment opportunities. And so we are not doing it this year. We hope this will also come back in the future years. The academy is an opportunity to really learn new stuff in a more kind of tutorial kind of fashion. And the seminar is what the main event is about. That's what it started. So what are we doing here actually? So first of all, this is kind of for many of you, this will be the first introduction to science, to the scientific process. So what is the scientific process? I'll tell you a little bit more about this, especially as far as conferences are concerned. But here you are enjoying your first scientific conference, most of you probably. So in this setting where you already did some science of your own, an important part of science is that you are not doing completely on your own, but you get feedback. You ask people what they think about your science, and this is what reviewing is all about. And then when the reviewers think, this is good science, or this is at least it's reasonable, and this is something people might want to read, then you publish it. And here is your first opportunity to publish something. So there is this thing, this booklet. All of you got this, and there's all your papers in here. So this is really a result you have produced for this conference. And then now that you have produced this result and published them, you can also now present them to everybody else and internationally. And maybe the most important aspect of this whole process is here, not standing here giving your talks and listening to them, but what happens in between and after the talks. The discussions with everybody else. So I think back then, at my first CESCG, so I met Jiří from Prague, and we were both interested in visibility, occlusion culling and so on. And I think we spent hours discussing this, and then we collaborated, and then Jiří came to Vienna and worked in Vienna together with me on a European project. We're very good friends as well ever since then. So this is an opportunity for all of you to find new friends, both private, both for your personal life as well as scientifically. Find your scientific friends here. It's a great opportunity. Talk to the other people and see what they are doing, and I'm sure you will find common interests, and this will be great for your personal life and also for your career. There's many examples where people who gave their first presentations here at this conference are now professors or researchers at important institutions all over the world. So here's a bit of some statistics. I don't know whether you can actually see this from back there. So as I said, in 1997 was the first CESCG, and for many years this was kind of a very steady attendance. So we reached attendance numbers of about 80 attendees. So this place was packed. There were, of course, here more than before, and then now with COVID and so on, we had actually to skip 2 years of actually gathering together. So I don't know, we estimated somehow the attendance in the previous 2 years, but it's very hard to do that from just YouTube numbers. I don't know who really watched live, who watched it afterwards, and so on. But this is just to give you an impression. Yeah. I know, but who really participated in it? We can have YouTube running and do something else, as I said, yes. But still, so you can see here, CESCG is a healthy event, and it has been ongoing for a very long time. And as I see here in your faces, I guess for many of you this will not be the last time, hopefully, so I guess it will continue to be ongoing for a long time. Let me tell you a little bit more about this whole process. So, first of all, what you experience is the review process. And since you're still students, we thought, and a really international conference, this is something that can be very frustrating. You write your first paper, send it to a conference, and it gets rejected. You send it to another conference, it gets rejected again. So we wanted to give you all the nice aspects of a scientific conference without this negative part, and we decided to skip the rejection part and get right to getting accepted. So, and you're a crowd that has been selected by your supervisors as being motivated students and interested in computer graphics, and so we work with the supervisors to make sure that you present your very best work here. But still, you get this feedback, and the feedback form is actually very similar to the big international conferences. That it's multinational, it's not something that's happening on campus in your university with a couple of people from next door. It's something where you meet people from all over the world. This is great. Then something which has cropped up in many conferences recently is fast-forward sessions. So programs have become so big, there's often parallel sessions, well, not at the CESCG, but many other conferences. It's very hard to pick your program and to understand what you should watch, and then it is fast forward. You'll enjoy it in a couple of minutes if I speed up a little bit and stop talking. Then you will see people think about how they can present the research in 20 seconds in a sometimes funny way. And the proceedings we have already mentioned, and there's very simple things. We all run around with badges. I mean, I think the last 2 years, probably nobody has ever worn a badge or something. You don't wear a badge at home if you're looking into your webcam. Then there's something that's called session chairs. So these are a couple of usually senior people, mostly part of the international program committee. And they moderate the session, so they make sure that people like me don't go so much over time, which I'm doing currently. And I have no session chair, if I'm lucky. Oh yeah, thank you for being the session chair. And they do a thing that they shouldn't need to do. They ask questions. But actually, what's important here, as I said, the thing that's important here is not only the talks, but what happens afterwards. And what afterwards is where you can communicate with the presenter. So you don't just watch and say, well, I didn't understand anything, but that's whatever. But you, there was this thing on this side, so can you explain this a bit more? Can you tell me about this? Raise your hand, ask a question. The session chairs will encourage you to do that, but please do so. We could actually give a bonus point to ask a question, but I trust you to be so happy to be in this crowd now that you will be very proactive in really raising your hand and asking people to ask questions. So you don't need to fear that the presenter will be annoyed or will fear your questions. He's eager to talk to you. So please do that. Engage with the presenters and in conversations. Well, and there is also one aspect that's important, that's coffee breaks. I heard someone say about conferences and talks, how people do talks. Well, that is an important aspect. You should time your talk well. So you shouldn't talk too long, because then all the good cookies will be gone once they will get to the coffee break. But you shouldn't be too short, because then people go out and the break is not served yet, the cookies are not there yet, so you will be bored. So just use the correct amount of time for your presentations. That's actually also a recommendation. And did I mention networking already? No, I didn't show that. No. Okay, the presentations, it should be 15 minutes per paper that you talk, and 7 minutes for the posters. Other poster presentations? Yes. Okay, fine. And about 5 minutes of discussion. If there is a bit more discussion, we can accommodate that, I guess. Yes. And yeah, another aspect of these conferences is that there is usually people who already have a lot of experience in research, who have done an interesting body of research, they come to this conference and tell you about it, what they have done. And these are the keynote speakers, the invited speakers. So I'm happy to say that Jiří Chmelík has agreed to take on this role for this conference. He's an important researcher. He has done very interesting work, and he will tell you all about it tomorrow. And the topic will be mixed reality research and education. Oh, today, I'm sorry. I think Martin on our internal discussion discussed like 20 times when should we do the keynote, Thursday or Friday, and switched so often that I got kind of lost. Yeah, then there's also the academy starting after this conference program. As I already said, this is getting more in-depth knowledge, more hands-on in some topics. I won't read the topics here, because it's Friday and Saturday. I think you probably saw that in the program already, so I invite you to take this opportunity. These are also experienced researchers in these topics here that we will tell you about the experiences and try to teach you something about that. And probably the most important program thing about CESCG is also the social program. So here you see it starts at 6 o'clock. Will not start at 6 o'clock. I think we will not be ready by that. So a little bit later, as soon as we're ready. So there's a couple of things planned. So important is the formal dinner. We sit together and have dinner together where there's opportunity to continue conversations and so on. There is a guided walk to Molepier, which is a peak. Martin, can you point to this peak? Do you see it? It's over there. So, Martin, is this kind of in competition with the dinner, or afterwards or before dinner?
It was supposed to be during the ITC meeting, which is right before the dinner. So the original plan was at 6-ish, and the winner is 19:15.
So let's see how things turn out. If at 7 we're still here and listening to talks, maybe the Molepier walk will be more private enjoyment after the dinner, but we will see.
We will see if the weather is fine, we can postpone the dinner as well. So there are some showers forecasted for the evening. No one knows when.
Some people will take a shower.
So maybe we just decided that the dinner will be 20 minutes later and we do another.
We will try to be very flexible, and we will also ask you what you want. And there's many other opportunities. I remember so many CESCG. There's ping pong tables, there's music jam sessions, so some people draw guitars, there's a piano, there's a piano there, you can see there's a piano there, which is always fun. I brought my flute and maybe other people. Did anybody bring any other instruments? I tried to make that point in our Discord before. Not sure. Well, let's see. You all brought your voices. You can sing some traditional Slovak folk songs. And we'll listen to that. And yeah, Friday there will be a castle tour. Martin has a lot of experience in giving these castle tours. He knows a lot about this castle already. And so on and so on. And then there we had game sessions of very politically incorrect games and so on. Yeah, more about that later. Yeah, and another important aspect of the conference is also the award program. So some of the people will go away here with awards. First there will be a Best Paper Award, which is selected by the International Program Committee. I say this again, so I haven't explained this yet. And there's also a Best Video Award. How many videos did we get this year? 2, so this will be a very tough decision. And there will be awards for the best presentation and the best poster. These will be selected by you. So you have voting sheets and these green dots. So if you look here, between the two sheets of your name, with your name on it, there's a green dot that you can stick on the poster that you like most. Please take this opportunity, and then there will be a best poster award. So this is actually something that's hard to get right. These badges. So I talked about badges, and actually I came from your graphics last week. They didn't get it right. They made a badge which had the name on one side and some arbitrary stuff on the back side, some tickets or whatever. And most people, I mean, some of them badge lips, and then they don't see the name anymore. So the first lesson to learn about badges is put the name on both sides and put the first say in big letters, because then you have this all this kind of this awkward social situation. Hi, yeah, and we try to avoid it by making this very easy to read, even for the ones who have very bad eyesight. So, okay, and yeah, the International Program Committee is actually the people who are responsible for selecting the program here. So they get, on the one hand, they are also responsible for getting you guys in to join and selecting the students, and also to review the papers. Because you know that the papers were distributed to, you got these reviews in, and these are the people, most of them who did reviews, so we thank them as well. And finally, something that is also very important for conferences is sponsors, because these things cost money. So this castle, to rent this castle costs money. It's actually not very cheap. And to make this event affordable for everybody who wants to attend, because we know that you do not get rich by being a student. So we try to get sponsors. We thank all these organizations here on this slide. So that Hvězda Research Center, which is a research center that was spawned by TU Wien, and they always sponsor this event. There's CAUS, where we have many colleagues here, and they also sponsor us as well. Procedural design, here is procedural design, is sponsoring this event by his presence, and many other. So Epic Games is sponsoring this, and Escape Motions, and what is SG? Production. Okay, so you can join for a beer. Okay, I think. You will be doing interviews, so you please be prepared to act as respondents. As interviewee. Okay, so I think that is more. I mean, I already thanked Martin. There would be so many other people to thank. Should we do that at the end of the conference, because we're running late? And yeah, this is. Well, that's it. This is the opening of CESCG. Enjoy, have a great time, have a great 2 or 3 days, and please engage in discussions, please contact everybody, please use these badges in the way that you actually talk to people, say, hey Michal, hey Dennis, hey Martin, and what are you doing, what are you researching currently, and so on. So I hope you enjoyed the conference, and now let's switch smoothly to the fast forward presentation. Thank you.
Hi, I'm Dominik. I finished my thesis on improvements in probe placement and dynamic diffuse global illumination. We have implemented the original work by Milović and evaluated its usage in architectural visualization. We have explored its pros and cons and presented improvements to avoid its artifacts. If you want to know about our improvements and how we dealt with those artifacts, come to my talk or see my paper.
I'm Michal Hvězda from Czech Technical University in Prague. In my paper, I evaluated a real-time global illumination algorithm called Dynamic Diffuse Global Illumination in terms of performance and quality of the final image. I detail my implementation of the algorithm and how it leverages modern ray-traced GPU hardware to compute diffuse light transfer for a given scene. If you would like to know more on how to implement such algorithm and see results of my evaluation, come to my talk. I'm looking forward to seeing you there.
Hello, I'm Wojtěch from the Czech Technical University in Prague. My goal was to create a web environment for city planners where they could explore large static and dynamic datasets. The system utilizes a versatile data model, several spatial and temporal data structures, and the custom styling language. I also thought about the interface and ended up using Lego models as a presentation medium. If you are interested, feel free to check out my presentation.
Hi, I'm Piliar from Pan-European University. In my work, I developed a real-time interconnection platform used to connect virtual and augmented reality devices called PVO-Go. The platform is implemented by utilizing commercially available software solutions such as Vuforia or photon networking. If you are interested in virtual or augmented reality devices, please feel free to check out my presentation.
Hello, I'm Sanja from the University of Sanja. In our paper, we evaluated how users perceive camera movement, one of the techniques of classical filmmaking, in 360 video. We recorded 3 sets of 360 videos with different amounts of movement and developed a VR application to present them to users. In order to test our hypotheses, we conducted a UX evaluation study in order to analyze whether this movement adds to immersion in VR or causes unbearable motion sickness. If you are interested in 360 video and VR, please come to our presentation and read our paper.
Hi, my name is Michaela and I wrote a state-of-the-art report about processing speed and comprehensibility of visualizations and texts. In my presentation, we will try to find answers for the questions if visualizations or texts are processed faster by humans and which one is better comprehensible.
Hello, my name is Michal. I am from the Slovak University of Technology, and together with my colleague Jakub, we study the impact of education on human visual attention. We conducted an eye-tracking study consisting of 3 modules on 2 groups of university students. We analyzed the differences in visual attention while freely viewing visual stimuli and completing visual search tasks. The participants of our study were students with different backgrounds in education, that is, technical and non-technical students. If you'd like to know the results of our study, we invite you to come and see our poster.
Hello, I'm Maroš from Slovak University of Technology, and the topic of my work is multi-class texture synthesis using generative adversarial networks, where I focus on controllable synthesis of multiple non-stationary textures from real environment. My solution provides both the controllability of texture class and also intra-class variations. If you're interested to hear more about this topic, I would like to invite you to my presentation.
Hello, my name is Tuscher. I'm from Budapest University of Technology and Economics, and I will talk about analyzing architectural floor plans using neural networks. I will present a system that is capable of obtaining a parametric representation of a floor plan and building a 3D model from this representation. If you're interested in this topic and want to know how to achieve this only from a 2D image, then come see my presentation on Friday. Thank you.
Hello, I'm Paul from Graz University of Technology. My paper is about training algorithms for sparse neural networks. I created 2 new algorithms for weight relocation using an approximation of the second-order derivative. Then I compared them to existing methods in terms of network accuracy and the computational cost of training. If you're interested in new ways to create more accurate and efficient neural networks, check out my presentation.
Hi, I'm Gaia and I'm a Erasmus student at the Charles University in Prague. For my master thesis, I'm working with 3D printers and renders. Our goal is to create a shader that will match the appearance of FDM printouts without explicitly modeling the geometry and reflectance characteristics. If you're interested in learning more, please come to my talk.
Hello, my name is Dennis Stebner. I'm a student at Vienna's University of Technology. In my work, we present a method for improving depth image integration in the Kinect Fusion algorithm for 3D surface reconstruction. To do that, point cloud information of previous depth images is aggregated as median vectors and used for 3D surface calculations. If you're interested in learning more, I invite you to my talk and see you there.
Diffusion-based methods, often inspired by nature, can be used as a tool for filling holes and even remeshing polygonal surfaces. We implemented a shrink wrapper tool for a variety of triangle meshes and tested the stability of our model. Curious about how we've done it? Feel free to come to my presentation on Friday.
So, fast forward, test 2019. There you go.
Next. So.
Wir werden noch die Sonnenschirme aufmachen.
Okay. Weil im Prinzip ist mit der Session weg.
Und dann schaltet auf Slide. Das geht first, wenn das weitergeht. Aber wir machen noch diese
Sonnenschirme.
Und die Leute müssen dann den Rechner präsentieren.
Das ist
Minutenpause ist okay.
Wirklich? Du brauchst das Sonnenschirm.
Damit sie die USB sagen.
Achso. Okay, I think we are presenting from this laptop, so we do a couple of minutes breaks for the 3 speakers of the next session, so Dominik, Michal and Wojtěch, to come here with the USB sticks and put the presentations on the laptop, okay? And we also, Martin wants to try to improve the sunscreens, so please go ahead, just plug yourself in somewhere. Yeah, you can.
All of them are full, but I can take out the
Yeah, you can remove them out. Here there's actually. Yeah, anyway. You can use a touchpad.
I just want to test if this video is running. This, should I copy it to somewhere?
You can just copy it to the desktop.
Desktop and create here present.
Yeah, that's why they're trying to shut the sunscreens.
Prepacz, chcesz z nim vyskúšať, že?
Okay.
Okay, next.
Nějaký pití.
So if anyone wants the printed proceedings, we have here A5 and A4. A few pieces, feel free. It's kind of take it and give back if you don't need it anymore.
There's a presentation directory over here.
They
You
are
can
over
just
here.
copy it
It's
here.
just for today. For tomorrow we have different booklets.
You need to pressing the FN button instead of the.
Yeah. Okay. I'll just.
Okay. Fine. Okay, next. This is control, yes,
okay.
yes. The other is the function key. Lenovo has this further up. It's the Lenovo.
Can I just try to play a video?
Sure.
Yeah. Yeah, and I can see. Okay, fine.
Looks good, yes.
Should I close it?
Nothing yet? So, please find your seats. We're trying to start the session. And I will try to give a first demonstration of what it is, what a session chair does. The first task of the session chair is to get everybody to sit in the session. So please have your seats. And so welcome to the first presentation session of CESCG. The name of the session is Rendering and Visualization. Well, that is an interesting name. It is a very broad. But we know one of the tasks of the program committee chair is always to put papers together into sessions, and sometimes this is not so easy to find papers that fit together. So you sometimes get these names, these session names that have two very, well, only vaguely related things and put them into one session. Okay, but let's see, maybe these papers have something together. They have something together in this session. You're watching them and you will ask questions about these. And I now invite, so there's two microphones here, so for all of you who are speakers, this one you use so that everybody else here can understand you. And this here, this is for the audience on YouTube. Hi, welcome. So we're in the first session. We are starting rendering and visualization. So, and the first speaker will be Dominik Roháček from the Charles University in Prague, and he will talk about improving probes in dynamic diffuse global illumination, as you have seen in the fast forward. So please, Dominik, give us the first presentation at CESCG in 2022. And your I will now switch here to slides and speaker. And I will
need my slides.
give you your slides, and this is defend. And then we just need to, well...
Does it full screen?
The only problem is, Martin, this is a PDF, so I think we should switch to duplicate, right? Because otherwise he won't see his slides. Yes. Oops, no. F, yeah, Windows, okay. Duplicate, and then it's Control L.
Can we open it in...
There is no alphabet reader here.
Okay, let's hope it works. Okay.
Thank you.
You have the floor. You can use this.
So, hello and welcome to my speak about my thesis, which I finished just a few months ago, on the improvements in the probe placement in dynamic diffuse global illumination. So to outline my speak, first I will be talking about motivation, then I will introduce a bit dynamic diffuse global illumination, the original technique from Milović, then I will present our work, and then there will be a time for a discussion. So for motivation, it would be really easy to just show two images, one with just the direct illumination, second one with the full global illumination. But the motivation was kind of broader, because the motivation was to enable or speed up the workflow in the company which is doing architectural visualization. So the workflow is usually that the architect places the model into the scene, he sets up the lighting, and he just presses the button to render, and he waits and do a coffee and waits a bit more. So we wanted to allow them to see at least some crude approximation of a global illumination in the scene before he will make a coffee and wait for the render. And the secondary motivation to do this work was to explore the new technology from NVIDIA called RTX. The RTX was presented with a new series of cards. It's already right now second series with the RTX technology. They presented a new RT cores in their graphics cards, and it enables you to do a fast scene versus ray intersection. And also it came with a new graphics pipeline on GPU, and we wanted to explore what we can do with this pipeline. Pipeline is pretty easy. It allows you to upload your scene to graphics card. It goes to proprietary acceleration structure, and it allows you to generate rays. Then you can a little bit modify how the scene will look like. It don't need to be just a triangular mesh. You can place implicit surfaces or spheres or whatever you are able to describe in a shader, and you will get out the hit. Whether you hit something, you get what you would expect from path tracer. So first we explored the possibilities which we can implement to the physics engine, and we settled out on dynamic diffuse global illumination, which turned out not to be the best first choice, but we tried to improve it, and that's the core of this talk. So what is the dynamic diffuse global illumination? I will talk briefly about that because I found out that the next speaker has this topic, so I don't want to steal so much. So it's a grid-based technique where you are caching the irradiance inside probes, and dynamic here stands that it is updated regularly. It's not pre-computed as for example photon mapping or light mapping that is used in gaming engines today sometimes, and from the regular grid you can already see the first problems. So I will go through the problems we encountered and we tried to fix.
So first of the artifacts we encountered was that many of the probes are inside the geometry, and this would be a smaller problem if we were not doing the architectural visualization. But in architectural visualization, you've got the walls, they can be aligned with the grid, and just many of your probes could be submerged inside the geometry and useless for your indirect illumination. Secondary problem we encountered after implementing the original paper was this weird artifact that wasn't obvious at the start where it comes from. So now I will go through our improvements. So first of all, we tried to deal with the probes being submerged inside the geometry. Here you can see that many probes, here are 4, and some in the wall that you cannot see are submerged, and there are artifacts around them. So how do we deal with that? From the ray tracer, we are storing 2 values in each pixel of probe data. We store the depth information and we store the irradiance. So we use the depth information to decide which probe is submerged or even too close to the geometry, and we try to move them. But in the real time, we have a problem with offenses in our pipeline. If we want to read previous value and decide a new value of the pixel in the pipeline, we need to make a staging texture, which could lead to synchronization of a pipeline. So we decided to show the random pattern. It's a spiral pattern on which it is moving as long as it is submerged or too close to the geometry. And why do we want to get it away from the geometry? Well, because when you are too close to the geometry, almost half of your probe is representing very small patch of the geometry on the wall. And this way you are underusing your texture space. So how this turned out, you can see that all 4 probes got outside of the geometry and the weird artifact here disappeared almost completely. This led to a better distribution of the error across your world and less distraction for your architects. When we moved the probes, we unfortunately came across a different problem because the probes are being filtered by trainer filtering in the probe cage. But if you make your probe cage unregular, you cannot use the simple original filtering. So we also had to fix this one and account for the movement of the probes. The secondary problem you saw on the image was actually caused by the pretty interesting problem.
Just go on.
Okay, so and the problem was that if you place your probe somewhere near the geometry, okay, it's not even there, so maybe I will. Okay, so if you place your probe near to the geometry and your probe cage is ending with another probe there, some of your rays could go to the infinity outside of your probe cage. And if you account for those ones in the depth information, which is stored as Chebyshev's coefficient, it will prolong your depth information from that probe. So the solution was actually pretty easy. You just have to discard all the samples that are longer than the main diagonal of your probe cage. This way we get rid of artifacts that were occurring on the weird spaces on the edge of your scene or your geometry. This was actually caused by this infinite rays, which were accounted into the average of the depths. So this summarizes my presentation. What we did was a better placement of the probes. We also improved the filtering, and we described some missing details from the paper. on the clamping of the depths. And to show you the final result, I hope I will not break this anymore. There's a comparison and there is a space for the discussion, as I mentioned at the beginning. Any questions?
So thank you for this first presentation at Real Life CESCG. You did a great job. Now I invite you to do a great job as well. Ask questions. So who has a question? Maybe I start with one. So you have set this probe cage and you have this problem of intersecting probes. Why not remove all the probes that intersect the geometry in the pre-processing step?
Because of how the probes are stored in the memory, you will just still waste your memory to represent such data, and you are still missing part of the information on the lighting. So if the probe is inside the wall and you move it on one side of the wall, you still get better information on lighting than just avoiding it completely. There could be something in between the probe cage and the wall.
So what do you do with the probes that are like completely inside, I don't know, objects or so? And you have a cupboard or whatever, and some probes will end up there. So do you also notice those that are completely covered in the probe?
Yeah.
Can you move them out?
We move them out to some extent. You cannot move them more than half of the probe length of the probe cage, because otherwise probe could go other ways around and you will not achieve anything. And after some while you found out that they are dead and unusable, so you waste still the memory, but you at least tried, or the geometry is dynamic, you still can get out.
Okay. That gave you guys enough time to think about more questions. Otherwise, I just select randomly some people.
Yes! I have a question. In your motivation at the beginning, you mentioned that the primary use case is to help architects to speed up their visualizations, right? And my question is whether you collaborate with someone or thought about collaborating with someone who produces the software for the architect, or if you are in contact with someone who could use your implementation.
Oh, thank you, Vojta. Maybe I didn't mention that well. Actually, this was done for a company that developed the engine and the path tracer. And that was one of the main benefits of working with them, because we had a huge data set where we could try and find those artifacts.
So they're using it now, or they're still working on?
They changed its technology completely, but the decision was because of Unreal Engine, which is just moving way faster.
Okay, I see. Any more questions? Yes.
Okay, so how much scalable is the solution? Like, how many spheres or probes you can render, like tens or hundreds or thousands? Or?
The scene I presented here was something like 2,000 probes. The data is pretty small. The depth information is 16 by 16 pixels per one probe, and the irradiance is even 8 by 8. So the memory footprint is not that high.
But can you scale it up like 10 times or 100 times? Or?
Not really, because the RTX technology speeds up your ray tracing, but there is still some limit, and the biggest bottleneck for us was actually the RTX part. The integration and so on was just negligible.
Okay, thanks.
Okay.
Well, you teased us at the beginning that when you said that it turned out that it wasn't the right choice, this technique. What would have been the right choice in your mind?
From what we went through afterwards, probably global elimination based on circles, because you are spawning your caches dynamically with your geometry. And for example, as I mentioned, you have visualizations of a lot of straight walls, and if you align the straight wall with the pattern of the grid, you just lost a lot of probes there.
Okay. Any more? Otherwise, let's give a big hand again. we move from the Charles University, Technical University, Michal, Okay, find the presentation and tell us about we should have all the cards now that you know how to improve and use an Illumination, find out how to implement this and what is innovation about. So let's see that. How the hell? What do you need to add? Do you want to present a few?
Yeah.
A few. I'm going to extend again. And then you can just press
Is it FN?
AFN effect. I'll just check.
So hi everyone. My name is Hector. Why would you? Hi everyone. My name is Michal. I'm from the Czech University in Prague, and I'll be telling you about Illumination. So first off, what is Illumination and why do we actually care? Well, the rendering equation tells us that the outgoing light from the surface is some emissive light every internal light distribution from every possible angle. So if we want to actually add the direction distribution, we actually need to compute it as well to high degree integrals. So as you can imagine. That global illumination rather difficult to actually achieve. For some static scenes with really diffuse material, a lot of materials limited. For example, glossy materials. It's actually doable, but still not really. And if you want to actually do it in real time and for dynamic scenes. We need what if we can't compute it? What if we just approximate it? And here is where dynamic diffuse combination comes in. Yeah. Thank you. So what is the dynamic diffuse combination? The algorithm belongs to a class irradiance algorithms, which means that instead of sampling the scene through every pixel of a camera, these algorithms make use of samples and probes placed in the scene. And here are the steps that the dynamic diffuse takes to actually compute. Sorry. Okay. So to be able to scroll. So here are the steps that actually makes to compute the diffuse combination. First, we're given scene. We initialize a groups when developing the scene. Then for every frame we generate rays from each of the groups. Then we sample those rays and shade them by direct illumination and indirect illumination. This is done by sampling existing data inside the probes. And lastly, we update the data inside the probes. So first off. It's correct. It's better. Yeah. First off, representation. Let's the algorithm uses uniform enveloping the scene, place, groups, vertices. Perfect is stored inside an atlas of the map. We use two such atlases. One for idiot and the second for step values. As you can see in the top right corner. These atlases are encoded octahedral encoding, which is shown in the bottom images.
In each frame, we generate M rays for each road and road. Now redundance field. Each ray has its origin probe center. And since we want to sample somewhat uniformly, DJI uses spherical Fibonacci points to sample and direction across the unit sphere, as shown on the image. These rays are then badged together to two textures. Where one contains origins of the rays, and the second the directions. Rays are in cast into the scene, for which we use computational implementation about the engine. Each ray samples the geometry and data about roles, positions, normals, and material attributes, albedo, reflection, and transmissive and emissive terms. These attributes are stored inside G-buffer-like structure, circle buffer, which is actually very similar to G-buffer in the sense that it's just a set of textures for each of those attributes, and we even use it as a standard G-buffer. Here you can see part of the circle buffer for the box scene on the right of the image. Each row of ray samples for one probe. So we have albedo, attributes, normals, positions. For the scene, emissive and transmissive terms pretty much black textures, so I won't be showing them. Now that we have some data about geometry, we can start shading our rays. So for each sample, for example, visibility, shadow mapping, standard naive shadow mapping, and direction from each light source in the scene. Then we also add indirect contribution from previous frames by sampling the field. Finally, we can update the probe as is. The update is rather simple. We just for each pixel in a map compute a mean of all ray contributions of the particular probe weighted by the angle in the rays direction and the octagonal direction according to the map in the map. We then blend this new value, the old one, using hysteresis temporal hysteresis parameter. For the depth atlas, pretty much the same. But in addition, we also in addition to depth values, we also store the square values, which are used for variance computation during sampling of the field. That we have updated probes, we can start rendering the final image. The final image is the same way as rationing. We compute illumination and add under vision sample from the field for a given sample. So as you can see, the first image is illumination. The second are direct illumination, and the final image shows illumination. Here are my results of the implementation. On the graph you can see ray tracing throughput of the method, and the table shows the timing steps of the algorithm, which confirms my colleagues the ray tracing actually is a bottleneck. Now to the quality the algorithm was tested on a number of scenes. Some of them were mine, others were sourcing in research exhibit capital or San Miguel. As ground truth decided to use path-based images to show accuracy difference. On the first image you can see DJI's final image. Below is the path-based reference. And the flip difference. The probe density for the San Miguel scene was 16 by 8 by 15. This is our global illumination box. Again, there's you can see the DJI image reference and flip difference, where the probe density is 16 by 16. here's the Sympathic scene. On the first image is GI, reference, and density was 6 by 12. As you can notice, the Sympathic was not really the best case for the GI, since the GI actually overdominated the scene. It shouldn't be this red. And here are some videos. So this is our global illumination box, sliding, ceiling, floods the scene with light. In a moment, you will be able to see the lag by the temporal parameter. When the ceiling closes, the scene should be light, but instead slowly shifting towards it. Right now. And here's a chronal scene with two objects, where we show the color bleeding produced by the method. So, in conclusion, I implemented dynamic illumination. For the future work, I'm focusing on asserting the probe update by means of budgeting and smarter probe placement. So thank you for your attention. Do you have any questions?
Now we know a lot more about GI. Yes.
I want to ask how is the fleet defined? I'm not familiar with it. I want to ask second question if it is the standard way to compute differences and try different techniques to compare.
As far as I know, there are no other methods such as Sims, I believe, or again the flip, which from what I gathered, actually incorporates human vision into the equation. But for more information, I'll have to lead you to their website.
And how is the fleet defined? Can you tell more?
Yeah, sorry.
Okay, I will read the
Yes.
So, do you know how many rays you could actually shoot per frame, or how many or four?
We usually use 64 rays per probe, but every frame. Yeah. So 16 by 16 probes every single probe has 64 rays. Which as the graph showed, it's actually good. It's actually about 500 rays per probe. 40 setup.
Hey, we're there. I have one question. Combination previous. Your colleague showed some artifacts usually use method. So I'm confused. Did you encounter?
Yeah. Of course we did. I actually panicked doing this slide. There are many artifacts from the geometry, which pretty much. Since we are sampling cage, if one is geometry and we do not actually call it, his values are pretty much sample, which leads to I don't know weird shadowing on the surface. About the artifact with the culling of depth, I think the max distance. We actually during the implementation, I encountered as well. After looking through the reference source, I actually found that they actually mention it, but not the paper, in the source code.
So basically, my question was like if you dealt with those.
Yeah, I did. My thesis actually solves the geometry by calling them.
Okay, so basically different style than style.
Yeah.
Okay, then.
Yeah, that's what I suggested. Okay.
Can I have a set that you are storing origins and some textures? That's some constraint system.
That's a constraint really, which takes only textures for race.
So you implemented this as your own system or
it's implemented in G3D framework.
Okay. That always
Yeah. The paper pretty much focuses on the implementation just for GI, not for tracing.
Okay. The great opportunity for collaboration. Currently in the first university here. Both working on the same topic. Any other final questions? Then thank you again. Now we move on to a different topic. Now the visualization part of rendering and visualization, and that is Wojtěch, Tomas, implementation of urban data visualization. Please come to the stage and let's stop this presentation. You will find yours hopefully.
F5. Yeah, can you? Thank you. Sure. So hello. Hello. My name is Wojtěch, and I'm from Czech University, and I would like to present my paper of urban data visualization. And I would like to start by setting out the goal. The goal is to create an open visualization tool for city planners, but not just for city planners, also for developers, other stakeholders, and also programmers. And you might think why we should even try such another visualization toolkit. Aren't there enough visualization toolkits already? And the question is, and the answer is well, there's a problem. The problem is that when you collaborate with city planners, they keep coming up with newer questions, and that's okay because the answers. But the problem is when you realize there's a programmer behind all of this, preparing visualizations for them, and they're constantly bombarding by unending stream of requests. And that's the problem because the delivery time for the programmer shortens, and maybe there is an opportunity to solve this problem. This was me on the right side for the last year. Yeah. What should we do about it? Well, there are a few properties which city planners require, and it's to make a visualization really shared. So it should be on the web. It should support 3D, and there are also other properties that the visualization should have. And most importantly, you have to realize that we are dealing with large data sets. So there's usually some kind of pre-processing of the geometry. So I started laid out some basic structure. The structure is pretty simple. You need some data storage. You need to pre-process the data, and then you have to present it. And one of the required properties was a simple setup to be able like prepare visualization really quick. So instead of using databases, I tried to minimize the dependencies and just use straight out files storing the data into a custom hierarchy of files. Yeah. Then of course you have the data, which I will talk about later. And then there's the presentation. Of course, on the web we are still kind of waiting for the GPU. I had to use WebGL library, and also I was considering playing with some other methods of presentation. I will show you in the example later. Here is an example for some of you familiar with the city of Prague. The framework supports both static datasets as well as dynamic datasets. Yeah. So now let's talk about what's behind the visualization. To be able to process a large data, we need to use the out-of-core memory. Some of you they don't know what the out-of-core memory like that means. It means that you have to store the data you are not working with currently on the disk, and then load it into the memory later when you actually need it. That's one part of data processing. Also regarding data storage, I decided to implement very simple structure of data to store the metadata behind the geometry in simple JSON files, and store the geometry directly in the form of GL buffers encoded ready for loading. To optimize the geometry and to load to enable loading of visible geometry, I decided to go with a simple regular grid and to slice the geometry into tiles, and then combine the geometry back together into tiles, so I can load a single tile at once. It's pretty good for streaming the data into the viewer. Here's an example. This is what you usually see in the viewport, and when you zoom out a little bit and spread it out, you can see that the viewer of course loads only the visible tiles which are in the viewport. Combining datasets together is also pretty useful. It's for example if you have a data range, I'll show you later, and the dataset specifies the utilization of the line. You can combine those across dimensions, three-dimensional onto two-dimensional and back, and then you can project it back in 3D and combine it with other datasets. I utilized double R-trees and double R-trees to speed up the computation section of the datasets. Yeah. And another pretty useful feature. Thank you. is styling language which I have implemented. It is metadata styling language, which is pretty similar to how HTML and CSS works. You have two sets of documents. One describes the structure, which is geometry, and the other one describes the appearance. You can see the short example of how it looks. It reminds you of CSS. On the right, there's the unstyled version. On the bottom, it's the same geometry after the application of the style. This is all done in the browser after dynamic load of the geometry. Now, let's move some examples and other presentation media, because so far you have seen only being project usually on the screen, City Planner. We have experimented with presentation versions, Lego, everybody loves Lego, and the framework allows you to transform geometry into a Lego model, and you can actually build it, not ray traced or anything, a real physical model. We have built it's the church of Saint Ludmila on the Náměstí in Prague, and we have projected the style version of the dataset from on top of the Lego model. Of course, you can say that small models are nothing. It's just simple projection. Okay. I say we can also 3D print the model, and you can project on top of the 3D printed model. This is also not a ray trace. This is a camp in Prague. It's about 2 meters long model of the Žižské nádraží. Yeah. Here are some more pictures. And another example of where we use the framework is the visualization of a pre-development area in the middle of Prague. Here is the proposed new version of the urban area, and here is the actual current state. This is what you have seen before, but this is a combination of two datasets, the land use and the terrain and buildings together. You can see there's the spot in the middle, which is waiting for the new buildings, and here is the combined version altogether. You can, of course, style it as well. Here's another example. This is just a static snapshot, but we have played with the Maxim simulation software, if you are familiar with it. And maybe if you are familiar with it, you also know that there is only one single program called VIA, which supports the visualization of the output. Well, not anymore. We also supported it. You can upload the XML file from the Maxim into our software and visualize it. The framework comes in several packages. The preprocessing comes in the metaset package and visualization, as well as graphical user interface, which you can see up there, comes in a second Python package. Some performance tests, because we of course had to benchmark it. We tested the scalability of memory usage using the core memory technique, and you can see that the dataset, which usually require about 2 megabytes, can be scaled down to use about 250 megabytes. While being processed, it can go up a little bit, up to 500 megabytes. And for the rendering, you can see as well the memory usage can be limited, and the frame rate for the average dataset or combination of datasets. We are talking about, I don't know, about 100,000 triangles per tile, and in your viewport there is usually about 16 tiles. The frame rate goes from 30 to 60 frames per second usually, so it's pretty stable. So, in conclusion, we experimented with different approaches than the usual city planners and the visualization company state, and we tried to build an open system ready for extension. We tested it in cooperation with the Prague Institute of Planning and Development last year, and the packages are available as Python packages. There are some dependencies, but of course, if you want to use it, you can. So, thank you for your attention.
I'm sure.
Yeah. Thank you. The solution is that we try to streamline the most time-intensive things for programmers, like setting up, simplifying the setup. Then there is a graphical user interface for the planners, but on the back end, programmers can modify it on the fly and upload new datasets and server or locally, while the city planners already work with the data. So it's open from both sides. For the city planners, they can view it, they can modify it a bit, maybe styling. You choose different, I don't know, for example, they usually play with styles, the city planners, and brought up different metadata and visualize different metadata and then generate new demands, and we in the same time, almost at the same time, could implement like extension to the system and like deploy it to the existing instance of the software on the server.
Did you have a case when it was sufficient to just layer on the metadata to achieve what you wanted for some request?
Yeah, well, part of the process was also exploring what they actually want, because one of the basic problems is that they came to us, or to me, and said that the visualization setup usually takes too long, but we don't know exactly what we want. So, the part of the process was exploring what they actually want. Of course, there were some instances where we had to say, no, we cannot do that using our system. For example, when they came, yeah, sure, that's something that's happening right now, when they came with the request to visualize dynamic lines, not just points, maybe points, but dynamic lines actually. We had to postpone that for later.
Do you have cars? Moving cars?
Yeah, we do. We do.
Lights moving around?
No. They're moving cars. Sure.
So, I guess that was really your question, but so you showed that a 3D printed model and then some check mapping, right? Would you benefit also from colorful 3D prints, or is this actually beneficial? Would you have like a single color print?
Excellent question, thank you. We always try to make it as white as possible. Yeah, as bad as it sounds. And the reason is we want to project the visualization on top of it, so that's the main reason. Yeah, sure.
So, have you thought about representing autographs or figures, like Metrodome?
Yeah,
or
that's sure. Yeah. Yes, we gave it a thought. That's one of the things we had to postpone for now, but it's an open problem currently in Prague being discussed how to visualize this way.
I follow up the question of 3D printing and projection. Does the software somehow help you set up the projection anyway, or do you do it manually somehow?
Yeah. When you the software supports exporting to geometry, so you can use geometry for the 3D printing, and it usually comes with the coordinates, so you can actually like align the view exactly according to the coordinates. But to be honest, we use Touch Designer for the finishing touches. Yeah.
Yes.
What kind of data can you use? Can you use data from OpenStreetMap, for instance?
Yeah, it's not directly supported in the system, but we work with OpenStreetMap's data and transform it like almost manually, but it's not manually, it's automatic, but transform it and then upload it to the system. Yeah, but like we support GeoJSONs, mainly shapefiles, of course. We are also working on support for standard formats like DWG and other CAD formats, which architects usually use.
So, there's another common source, architects.
Yeah.
Can exchange about what do you think about architects? Andre.
You have a physical model. Say light source in your model.
Light source. I'm sorry, I'm not sure.
I need the sun, for instance. Do you print the sun?
No. It's the light model is mainly a modified height map, which is being pre-processed. In the paper, I went into a little more detail. It's basically the rasterized version, rasterized height map, which is then filtered using a median filter. We have tried a number of filters, and as strange as it sounds, the Center of Architecture in Prague usually is looking for some new, fresh ways to present the data in the new center. So yeah, that was part of the design actually.
Yeah, but my son comes around with the place.
Yeah, but that's exactly the use case, to let children assemble the model. Actually, it's funny you are saying that because one of the use cases is also you can place tracking markers on top of the model, and you can put a camera next to the projector, and you can put an another software, which my colleague working on currently in the company I am at, and then you can like monitor the changes in the model, and the kids can also exchange trackers. So if you connect all of this to a simulation software, then you have an interactive model of city, which is also like fun to play with for kids.
Oh, that's great. That's maybe safer to interact than a design model.
Yeah, sure.
Yeah. Quite famous. But it will be more expensive. Okay. Yeah, then thank you for this. We are in the lucky situation that nobody else can eat our cookies while we take longer for our sessions. So let's go have some cookies there and make some coffee. So first session.
Pronunciation correct. It's an easy task. Jiří, Chmelík.
Okay. I'm expecting using this level. I'm asking.
Well, I don't know about the technical details.
Try. Yeah, I think if you are able to use already set up, so it's easier. But if you have videos installed, I have a lot of videos, and I think it's huge PowerPoint files. So able to copy. Maybe the best is to check if you can use unplug mouse or something.
here's No, I think you.
Tak teraz to treba to riešiť? Treba to do odchodu. Hej, aj naši.
Naši to netreba.
Máme nejaký zoznam, alebo to je skade, alebo prepisoval, prekopíroval. No, toto je prekopírujem, to netreba žiadne externé informácie.
Tady někde. Tarčí do piv. Ať to nehodí.
Very good.
So welcome back everyone. The next session is going to be the keynote. Keynote is always something very special at any conference, but especially here, because this gives you a chance to hear from an experienced researcher and learn about an exciting field. This year it is something that is a very hot topic because of how virtual interaction became important in our lives in the final few years, hopefully not, so the last few years. And it is my great pleasure to introduce Jiří, Chmelík, who will present on virtual reality, mixed reality, and its applications, for instance, in education, which is something that I'm personally very excited about. So, please.
Thanks for nice.
Just let's welcome him with a big applause.
Okay, so thanks for nice introduction, and yeah, let's start. So, just few words about me. Currently I'm working as an assistant professor at Masaryk University since 2013, and basically my main teaching and research interest started as the area of computer graphics, and then I joined our HCI, Human-Computer Interaction Laboratory, and since then I am there. And few years back I started to develop our own game development curriculum, which I will be not talking about at all. But if you are interested in games, you can ask me. I'm basically guaranteeing the curriculum at Masaryk University. So, motivation. As was mentioned, I can see it now. Nowadays, AR and VR and mixed reality and extended reality and whatsoever is heavily used in almost all industry types, even games, which is industry, in entertainment, archaeology, architecture, as we seen. Are you doing some VR stuff, VR architectures or architects? You should. And so on and so on. Also, healthcare is quite a huge area. You can see nowadays a lot of different therapies and phobia treatments doing in VR because to some degree it makes sense. And even it's ongoing into our daily life. For example, head-up displays is kind of augmented reality, which start to be more common. But today I will be talking mainly about research in AR and VR and vice versa, using VR in other kinds of research and in education. So just very briefly, because probably all of you know these terms, just to be sure, that VR is some synthetic word produced usually by computer, and it's under real-time control of the user. So we are following these nice computer graphic lectures about real-time rendering. And there is virtual environment, which in most cases is thought as a synonym for VR. In some cases, the virtual environment is just the virtual world without the technology itself, like how the world looks like, and so on. So there is probably not single lecture about VR not mentioning this stuff. So this is Ivan Shatterland's Sword of Damocles, which is thought to be first VR system ever, and it's pretty old, as you can see. It was so heavy that it has to be supposed from ceiling, but still it supports stereoscopic rendering, it supports tracking of the user via some mechanical magic, basically. It has very limited resolution at all, but it works. It really works. It's 1968. Just about 50 years later, we are somewhere here,
This is already 2 years old, so today you can buy even something better. But just to give you an image, this is VR headset as we are using now. It's very lightweighted. You need no extra cables, no extra hardware, not even computer, because everything is computed directly inside this headset. It is about 2K resolution, and render it's about 90 or 120 Hertz. And yeah, it took us just 50 years to develop from this thing to this thing, so we can just thought about how it will look like after another 50 years, but yeah, I have no funny image for that. So yeah, but actually, like when I'm going back to this definition, even most of modern computer games will fulfill this definition, because yeah, modern games have some usually 3D world, and it's from first point of view of the user. We have real-time control and so on and so on. But this is like not VR as we thought about it. So quite key term here is immersion, where the immersion is really like when the user dives into VR and thinks that this virtual world is his real world, or in other words, that this virtual world is convincing enough to be, so we are not thinking about being in the some fake world. There is quite simple example of how VR could look like, and because you are a computer graphics guy, you can say, this super annoying elevator music, which is there on purpose. You can think, okay, the graphics doesn't look so exciting, it's definitely not some dynamic global illumination, there is a helicopter which is not even like rotating its propeller whatsoever, and from the flat screen it looks like dull. But I dare to say that every one of you, if you will try this in VR, and if you try to step on this plank and see the and hear the sound, how the wood is creaking and so on, each of you will feel at least a little bit like fear of hate, and you will be a little bit unsettled. Even though that the graphic is not completely realistic, it's basically not so good, let's say, but still the immersion is so high that you will believe and you will fear that you will fall down, and if you fall down in the VR, it's really unpleasant experience. Even if you know that you are standing on like solid surface and so on, and nothing can hit you. Okay, so let's go on. The second, today's maybe even more discussed technology is augmented reality, where the user is not completely immersed in a fake world or virtual world, but we are superimposing some computer-generated image onto user field of view. We are combining a real view with some artificial elements. And then there is terms like extended reality or mixed reality and many others, which basically are used weirdly in a lot of literature. If you check 10 papers, you will find 10 little bit different definitions. But basically by extended or mixed reality, we are meaning everything which is not our common reality. So including AR, VR, there is even virtual reality, there are like 5 other different terms under these. So back to augmented reality, there are some nice images how, or actually what you can buy this year, or maybe those last year, 5 the best AR glasses you can buy. So it looks very, very nice, but actually it doesn't none of these works as you would expect. Basically the single equipment which works as we, or at least researchers want, is this HoloLens, which is much less usable because it's much more bulky and heavy and whatsoever, but actually it does what we want. It has very advanced tracking of the surroundings. It could map virtual objects into your space. It has even finger tracking without no hardware, so if you do some gesture, it will track your fingers, and you can control it with it and so on. So yes, so with augmented reality, we are not so far as in VR, because we like this kind of devices with all of these functionality, but it's not happening yet. So this was just very brief introduction, and let's now check some weird areas of research. And basically
The main goal of this presentation is to show you, because most of you are very young researchers, to motivate you and show you that the AR and VR is quite broad and hopefully interesting topic of the research, and there is a lot of stuff happening and a lot of let's say crazy stuff happening in the research. So maybe if you have some funny, crazy or bold idea about research, I will show you that even some weird stuff could pass through and be researched and sometimes even published. Okay, so let's start with some hardware stuff. We are not doing that at our university, so I'll just mention, just to basically entertain you few not so common stuff. As a common stuff, I consider, of course, the research of new displays, like with high resolution and better frequency and low latency and so on, or some better sensors or better tracking of fingers, or even full body, because now they are trying to, even with the headset, track your full bodies, to have some full body avatar, or even lips, which would be nice to have lip tracking, but it's quite hard to do it if your face is covered by the headset. But some uncommon stuff is, for example, in hand tracking and especially feedback. Because if we are talking just about tracking, that we need just to track how user is moving his fingers, that's basically not done, but we can do that already. We can do that with cameras that are on the headset and with some very clever software tools and image processing. But what about if we have some haptic feedback, some force feedback, that we can actually touch something and feel the resistance of solid surface? That's much harder case, and apart from sci-fi movie, where it's like pretty common, in reality it looks like something like this, which works, and it works awesome. You really can feel like the objects, you can make some pressure and so on. But this is something you don't want to like wear on every day. It's really like prototype-ish state of research, and this is from 2019. This was published this year, and it looks much less bulky, still bulky, but much less. And it combines this, as I mentioned, software tracking of the fingers with quite nice idea that the feedback, the physical or haptic feedback, is moved from the fingers to your forearm. Because still, when you are moving your fingers, you can like using these muscles. So if you can like stimulate these muscles, it can feel quite similar as if you are touching something or so on. So it's quite nice idea and quite like different idea than we believed before, when everybody was using these kind of gloves. And so yeah. So even with like new kind of like really interaction with human bodies is still involved. This was published, I think, in January this year. Or if you go even beyond, you can do something which is called haptic hologram. This is of course not usable when you are running around the room with VR headset and so on. You are limited to this small black plate on the desk. But actually the black plate is a field of ultrasound speakers which can emit specific field, and it works as a haptic feedback. So if you move your hand and like touch something, the speakers below can focus the ultrasounds in such a way that you really feel, for example, in this case, like the model of the heart. And in this case, it's coupled with augmented reality glasses. So you have this is like nice example of mixed reality, where user can see like his or her real hands combined with the virtual model, and not even see it, but even he can touch it. So yeah, that's quite nice technology. I've even seen example where they attach this ultrasound thing on top of the headset. So they were like emitting this field in front of the user, which looks like super promising. But then you find out it weighs like 1 kilo. So when you are moving your head, it's not once again usable for real situation. But yeah, a lot of new and interesting technologies. The thing which is maybe more like close to, or actually it is used in real life now, it's eye tracking. Maybe you witness, okay, control question, whoever witnessed eye tracking in any case, in any, nice, okay. And who witnessed eye tracking in VR? Yeah, a little bit less, but yeah. Good stuff or good news. Yeah, nowadays you can put eye tracker inside directly into VR headset, and this is how it looks like from inside. You basically track the eye movements, and it can detect like the iris against the rest of the eye, which is super nice, and it has a lot of applications, and I will show some of these later. But now for the hardware stuff, even more interesting stuff than just tracking where you are looking is actually tracking or using the focal distance. Because the focal, like we as a human beings are used to focal on different like distances, but that's not possible in VR. That's not possible even in like 2D movies. Like if you are watching 2D movie, like the camera operator is focusing for you. For example, if you are watching some dialogue between two persons, usually like camera is refocusing to the closer one and the end one, based on who is speaking. But in the VR, when we have the control of the camera, we want to have control over the focus. We want to focus on different stuff, but we are not able to without these kind of specific displays. And also, this is one kind of thing that can tell apart computer graphics, like really realistic computer graphics rendering from the reality, the like not proper focus. Typically, when you show somebody like very nice computer graphics rendering, they say yeah, it's awesome, but if it's somebody like experienced, they say yeah, but it's too much sharp. There is like everything is in focus. There's like common pitfall to create everything perfect and everything in focus, because we as human beings are used to see only part of the image out of the focus. But it again, like a few years back, this is 2018, they built very intricate system. It was like this is huge, but still, which is able to in real time track your focal length of your eyes, and based on this information, like refocus or blur actually the part of the image. So when you are trying to refocus in the virtual image, you actually are refocusing, and you are focusing on different distances inside this virtual image, which is quite awesome. Later, a different group tried to build like this multifocal stuff directly into this optics of virtual headset. And on the right, there is the first generation, which has some like physically moving, mechanically moving part. And on the left side, there's like third generation, I think, which is using even more like funny stuff, and they are using the set of liquid crystal lenses, and I think it's visible here. And I'm not sure if it's visible actually, but it should be. And depending on which of these lenses you will turn on and off, you can like refocus onto the different distance into off of like this virtual world. So yeah. So now we are able even to focus, even to track the human eyes of the user. And there is a lot of more of weird and funny hardware stuff. But I think most of us are doing basically software. So let's move to the software part, because yeah, every time when some new hardware, let's say toy, appears, there is need for some software to use it properly. Okay. So back to computer graphics, which should be our field. I feel we heard some nice talks about rendering. So you know that the one of the big tasks of the computer graphics is of course optimization of performance, like doing things faster, better, with better lighting and so on. And this is like specific for, or not specific for VR, this is common for all computer graphics. But with VR, there are some new challenges and new specific tasks. Because as I was mentioning, the VR headset, or basically all this stuff, is using some optics, because you have some display which is very close to your eye, and to like so the user, if the user want to perceive it correctly, there have to be some optics between the actual display and the human eye. But the optics typically somehow distorts the image. So if you want that user see this image undistorted, actually what we need to do is distort this image before putting it, before rendering on the display, and then through the optics is undistorted again. Okay, but nowadays we have like programmable pipelines, shaders and whatsoever. So if you render common image, it's pretty straightforward to like make this distortion and then pass it to the display. That's solved issue, and like yeah. But then somebody clever realized, and I think this was guys from NVIDIA, that actually when we have this undistorted image, and we are distorting it into this rounded image image display on the left, we are actually like compressing a lot of pixels from like the corner of the image into very few pixels that are at the end rendered. And this is like waste of pixels again. So why to not use something which they called multi-resolution rendering? And that's actually what they are doing now in this headset. Basically these areas which are in pink, they are rendered only in half resolution, because anyway they will be distorted and rendered in these smaller areas. And anyway, user is usually looking at the center of the image. So these like corners we are perceiving only with our like peripheral vision. So yeah, nobody will ever notice. In these blue areas, these corners are rendered only in like 1/4 of resolution. So yeah, that's a nice trick of computer graphics that helps like improve the rendering quite much. But now, if you can realize that we talk about this eye tracking, we can go even farther and create something which is called foveated rendering. And then, if we know where the user is looking actually on the image, we can render only this small part when he is looking in the full resolution, and everything else could be rendered in much less resolution, because anyway we will perceive it only with peripheral vision. So yeah, and with this like foveated rendering, we can save like I think 70% of our computation like budget, because we are rendering much less pixels, and like these corner areas we are rendering in very small resolution. Of course we need to do it pretty fast, but yeah, these eye trackings are working very fast, and now like current GPUs are also working very fast, so it's doable. And it's a very nice trick. Actually, user will never notice anything, but will save a huge amount of rendering. Another issue or another topic which is basically part of the image or computer graphics is image processing, and definitely you have some lectures of image processing, so you know that nowadays image processing is used for many things in these augmented reality glasses or virtual reality, basically for tracking the surroundings or detection of the floor. If you have some markers for detection of markers, or even for this finger tracking. Basically, a lot of stuff nowadays is done through image processing, because we have much better images than before, and we have much better hardware, including all of this machine learning and stuff that could process these images and take out data. But actually, it's not so new. There is a very funny and old example from 2013, actually, showing some AR. It's a very simple game, because if you are bored enough, you can buy this mug with marker, and then use your tablet or phone and play this AR basketball, because yeah, why not? Because it's very simple, because you need just to track this marker and align it in 3D space, and that's all. Yeah, 2013. Okay, but yeah, why not try to something more crazy? And we was working on some project with divers, which are diving obviously underwater. So what about to try to make some augmented reality underwater? And we have sound again. Yeah, let's enjoy. Awesome. Some bubbles. And if you are looking very hard, you will still see nothing. But on my screen there are some augmented reality markers somewhere hidden. The purpose of this video is to show you that underwater there are completely different conditions, because there is quite bad and rapidly changing lighting, and even more the water is not clear, because this is in the sea. There is a lot of turbidity in the water, so if you try to detect the markers, you will get like this blurred, does it work? No. This blurred image, and like common augmented reality frameworks for marker detection will not work, because they are not used to for this kind of input. So we thought, what about to do with that? And instead of developing our own like augmented reality solver for marker detection, we thought, okay, we will grab the video footage from the phone and enhance the video in real time, and then feed this enhanced video into the common AR core, and how it's called, I'm not sure which one we tested. I think with still like 3 of these already available augmented reality frameworks. But our goal was to like enhance the video in before. So we did with some partial success, but yeah, it was not very happy research. But at the end, it works. And here on one side, we should still see the footage from the phone, but on the other side, we should still see the footage what the diver see on his phone. And this is like some crude reconstruction of the building, because we were testing it in Italy with some sink to bridge. And yeah, you can imagine that now we have some underwater tourism where divers can actually see like what the place looked like before. In the reality, if they can see even something at all, they see just some small pieces of the wall and small pieces of this mosaic on the floor, and that was it. And if the water is bad, you don't see even yourself, so it doesn't work actually. Okay, so let's move on about perception. And I prepared these slides even before I noticed that there will be full session about perception and attention. So I will just tease you with some funny facts and let all the proper research for the next session. So with VR, one of the stuff with the perception is of course motion or simulation sickness, which is the stuff caused by basically sensory conflict. When you are moving in VR, your eyes are telling, for example, they are moving, but your inner ear and basically your guts are telling you that they are not moving because you are not like moving in the plane. And the conflict between these senses is basically like the main cause of the sensory or main cause of simulation sickness. So the question is, and this is like a huge research question because simulation sickness is like a huge thing in the VR, how to reduce the simulation sickness. And after a few years, we have a lot of guidelines and a lot of knowledge what to do and actually what not to do in VR to reduce simulation sickness. And for example, like very simple but mostly effective advice is just to avoid acceleration and deceleration. Because it's the same as when you are driving the car or when you are in the plane. The worst part of the plane is when it's starting and landing, when the speed is changing. And in VR it's the same. So these virtual roller coasters, which were popular a few years back, are typically like bad example what you should not do, because on a roller coaster the speed is changing rapidly and so on. But on the other hand, on the roller coaster typically they are in VR they are rendered with some kind of frame of reference. Basically, like you in VR you can see this like cage around you, and it was found out that this frame of reference quite well helps you to like settle in the VR. So if you have some frame of reference in VR, it helps you to reduce the simulation sickness. It's the same. The frame of reference could be, as I mentioned, like this cage of a roller coaster, or even the helmet if you are simulating, for example, a ride on the motorcycle, or even a nose. Because funny fact, like all of us can focus on the tip of our nose. And now you will try it, and now you will find it's super annoying because you can see tip of your nose. But don't worry, like in a few minutes you will forget about it and it will be fine. I will remind you at the end of the presentation. But they did this very funny research. It was Purdue University research, and they use a control group without any this like virtual nose, and they have experimental group where they edit just this like pretty huge rendering of the nose into the VR. And tell them, okay, go through this villa and do some stuff. And then they ask about motion sickness. And they find out that the experimental group with the nose really reported a smaller portion of motion sickness. So actually even like this kind of frame of reference could help and reduce the motion sickness. And what was even more surprising, when they were doing like this post-experimental questionnaires, the most of the users of this experimental group who were using this rendering with the nose didn't even notice that there is some nose, because we are so used to our nose that even in VR we are just ignoring it. So even this stuff like works in VR But sometimes it's like hard to realize that we can use these cheap tricks to improve our work. So yeah, some few facts or few mentioning about perception research. By now we know that in VR, quite common fact is underestimation of sizes. If you, for example, have this architectural visualization of the building, put it into the VR and let people walk through it, most of them will report that the building looks smaller. Because in VR we have some tendency to underestimate the sizes. Then they even realize that if you have any avatar in VR, because in many cases you don't have no avatar at all, but if you have some avatar, then there is a correlation between this underestimation and the avatar size. Because we are used to our size, and if we are in VR and we have some avatar of ourselves which has different size, then we like re-estimate our surroundings, and we do wrong estimations about the size. And the thing is that usually in VR, VR is not asking or measuring your real body size. All users have basically the same avatars of the same size, because nobody cares about to create personalized avatars to this kind of degree. And nowadays they are even trying to measure if there is some correlation of level of realism of this avatar and this perception of size and other stuff. So the idea is that if you have very stylized avatar, as I will show you on some our renderings, or you have very realistic avatar, even this could influence your perception of not even size but the whole virtual world. We did, as a funny research project, actually it was a bachelor thesis, the perception of the gravity in VR, because we are interested, we know that it's a little bit like motion sickness causing stuff, but still we want to try, or actually the student want to try, and I was not able to stop them, actually. So they designed some virtual environment where you can, for example, walk onto, from the floor to the wall, and walk on the floors, onto ceilings and stuff, or fly as a Superman, and this kind of stuff where you are breaking the laws of gravity. And actually the question was, how the user will be able to get with it, or if he will be able to navigate with such environment, and of course, what about motion sickness? So there is a video of from the student bachelor thesis, and now you can see some ramps, which on 2D screen looks mostly harmless, but on VR was super motion sickness causing. So then we tried teleports, which we are used to use teleport in VR, but you can have a fade teleport when basically the image fade out and then fade back, or you can have this dash teleport where actually you are seeing the movement. And when you are teleporting to your ceiling, it's a little bit weird that you actually see the movement. But in the end, I think the dash teleport was better, because when you see the movement, you better realize that what's happening to your surroundings. Of course, you cannot ignore the lamps which are hanging from the ceiling or the floor. But so it was nice and interesting experiment with the gravity. And one side finding we find that a lot of participants reported, there was no severe simulation sickness during the experiment, not even directly after, because it's quite common that the simulation sickness appears once you put down your headset. But second day, several participants reported us, I feel very dizzy and unsettled few hours of the experiment. And that was new for us, and we still don't have clue why this is happening with such a huge delay. So maybe we'll try to get them even more sick, and okay, maybe not. Okay, so let's move on for something completely different, and that's paragliding in VR. And just today I learned that the guy who invented not paraglide but parachute was supposedly from this village of Smolenice, which I never know, but yeah. So very nice historical connection with the place. But we are not doing parachuting, but paragliding, which is where you have more control of the stuff, and you are just flying around the terrain. And why not to try it in VR? So we applied, and actually we were lucky to be granted one of the proof of concept grant. And we have a lot of research questions like, okay, will it even work in VR? What about motion sickness? Because it's quite specific movement of the people above the terrain. Sorry? Good. And like our end goal was to use this kind of VR simulation for training purposes. Because paragliding is, let's say, to be honest, pretty dangerous sport, and you have some lectures on the ground, and they basically take you on the hill, push you, and fly. And in many cases it doesn't happen very well. So we had this idea that even if they try in virtual reality for a few times, like how to navigate or how to estimate the distances and so on, it will help them not kill them so fast. So we got some, this is like the first experiment with the terrain. And by the way, for the terrain, we built our in-house like tool which process some heat map and some orthophoto texture from these publicly available sources, not OpenStreetMaps, but similar kind of stuff. And it's not much visible, but actually the paragliding is moving forward. Nowadays we have much better rendering, which was finished like last week, so I didn't have the video yet. And yeah, so back to the questions. If this specific type of motion will even like work in VR, yeah, it works reasonably well. But when we tried it, or when the tutors from the paragliding school tried this, they reported immediately that the terrain seems flat for some reason. So once again, we know that already the VR causes like underestimation, but they are not tell us that the terrain is like small or something. They tell us that it's flat. And yeah, we just increase the height. Although we spent like 2 months like fiddling with numbers and trying to achieve as much like realistic terrain as possible. In the end, we says, okay, how much flat it is, and they says increase it like by 30%. I says, yeah, you are crazy. No, do it. We did like manually increase like the size of 30%. They tried again. Yeah, that's perfect. That looks realistic. So yeah, so like 2 months wasted, but never mind. What about motion sickness? This was surprising for me because I was expecting it will not work at all. I was rather skeptic for this, but actually it works. It's not causing so much motion sickness. But as we are working on the project and making it more and more realistic, even like movement of the parachute, rendering of the parachute, which was not visible at all on the video, we have we found out that the users are reporting like increased level of motion sickness. So the bigger, in this particular case, the bigger realism, the bigger motion sickness, which is a little bit surprising for us. And once again, maybe we'll throw out like few months of the work and give them like this crude rendering, which is not causing motion sickness, because the nice rendering is causing motion sickness, which is, yeah, okay. As you noticed, the terrain was not like really realistic. There was no global illumination at all. And that was also surprising because, of course, everybody will tell you that that's quite ugly. But almost nobody tell us that after a few seconds they basically forget about it, and it was not issue for them because they were focusing on like estimation the distance and avoiding these trees and avoiding these lines of high voltage, which are super dangerous, and so on. And they basically forget that the terrain has like 3 pixels per square meter or something for something like that. And at the end, they did test like the latest version. They tested with few like students of paragliding, and they reported that yeah, it's very usable and students like it, and reported yeah, and now I have a much better understanding of the terrain of like these currents of the hot air and so on. But at the same time, they reported they need like tons of other things, like for example, when they are landing, which is most crucial part. Then, because the terrain is not so detailed, they need more cues about like the line of distance estimation. So they ask us to add some trees or cars or some like 3D models of stuff around the landing place, so they can better estimate the distance and speed of landing and so on. But yeah, at the end it worked, which was nice. Okay, let's move on. About human-computer interactions, which basically was my original idea, and actually this was I think the first project we did with the VR. So yeah, that's another huge topic: user experience, human-computer interaction, and all of these like fancy words. And in VR, we are basically or not even VR, even AR or mixed reality, extended reality. We are reinventing the wheel a little bit, because even like simple question like how the menu should look like, and we are used to have some menus in desktop for like dozens of years. In VR, these rules are not applicable, not at all. They are somehow applicable, but still, menu in VR nowadays looks quite different than menu in desktop. Or actually how to manipulate with the objects which are not like on your reach, but for example you want to reach something which is far away, so you can use some laser pointer and grab it from a distance and so on, which is not possible in real, sadly, but in VR we can do that. The question is how. Or even typing the text, because that's like common pitfall that in VR it's very cumbersome and annoying to write anything longer than your name. Because you don't have like the physical keyboard, and if you have some virtual keyboard, when you are typing like one letter after another, it's super slow and super annoying. Okay, so back somewhere in 2017, where like this first of these headset like HTC Vive and Oculus DK2 or something was released, we had this simple hypothesis that interaction in virtual environment could be faster or will be faster in the than in desktop for like well-suited 3D manipulation task. Because we are doing some cooperation with archaeology guy, we are doing cooperation with a lot of weird group of people, and this time archaeological, and they had this task that when they found some artifact, for example a human skull, it's not usually, but sometimes it's broken to many pieces, and they need to assemble it. Nowadays they are not doing it in like physical form, that gluing the pieces together. They do the trick that they scan each piece with a super precise 3D scanner, and then doing everything digitally, and the original fragments are somewhere in the deposit. And usually they are using some specific softwares for them, but still it's something like simplified Blender. You are still like using a mouse and like 87 different shortcuts to manipulate with the stuff in the desktop. So I was thinking, okay, this should work in the VR. So we tried design some stuff. We asked them for some data, so this is like real data of some unhappy person who died several centuries ago. And we designed this kind of virtual environment when you can manipulate the stuff, but in the center of the room there is no gravity. Outside there is common gravity. And basically you can just grab some stuff, put it there, and manipulate and try to assemble in this case the skull. The only stuff I'm able to do is the jaws, so that's why I'm showing it, but never mind. And because like this is pretty natural, because you are just grabbing stuff and rotating stuff, but for the really precise manipulation we added this kind of like gizmo-based manipulation, even with like you can set the precision, so if you set it down, now if you move your hand like 10 centimeters, the fragment will move only 1 centimeter, so you can really precise move it or rotate it by a single axis. And by this manner you can assemble whole stuff. There is a lot of more functionality like grouping stuff together and so, but this is not so funny. So yeah, we did this virtual environment, and to like prove our hypothesis, we did some comparison study with 10 students of archaeology, and they really know like how the human skull looks like, so they were much better than me. And I think this is single graph in the presentation, and it's not even in color. But the dark bars are for the desktop environment, and the bright bars are for the VR. And the y-axis is basically time. So what the graph is telling you that each one of the participants was faster, because all of them tried to assemble the skull both in the desktop, in VR, in randomized order, and all of them were much faster using VR with the same kind of precision, which was also measured. And yeah, so it was nice proof that VR really could be useful for this kind of 3D manipulation task. And then, because we like diving and we like paragliding, but diving. So we had this super crazy idea of why not to let divers to write or type underwater, which is super uncommon. But there are some cases where you really need to make some notes underwater. But problem is that if you noticed on the video, the thing which was the diver holding in hand was not just the phone, it was phone in super bulky waterproof case. And the case basically disables the touch interface. So you don't have like touch display on your phone, you have only like 4 buttons on the side, and that's all. So how you want to type if you have just 4 buttons? So we had some ideas and we tried them. One was using common QWERTY keyboard when you are using tilting of the device to move this small red dot. So you tilt the device and then hit the button when the red dot was on correct letter. And then we had this, and this like works, but the problem is that you have like 2 degrees of freedom, and it's very like sensitive to the rotation. And we are underwater where there are some current of water and so on, so you are not able to like really fiddling with the device in 2 axes. So we tried that. This stuff, which is basically the fan of the letters, and you need only 1 axis to rotate it and select the correct letter. But still, there is too much letters and it's too much unprecise. So we came up with this idea when it's like 2-step process. And in first step you just select the group of letter, and in the second step you select one of letter from this group. And once again we did user study, and I think this was most weird and fun user study ever, because we did it in public pool in the Brno. So other during like common hours. So other people were just swimming there, and we were doing some super weird stuff with phones and cameras, and they look on us really like unhappy. But in the end, we find out that we did both qualitative and quantitative measuring, and the hard data tell us that actually the third method, this 2-step method, was faster and with least number of typos. But the questionnaires from users tell us totally opposite, and they tell us that this method is least preferable and least usable for them. And yeah, that's happened quite often in VR and AR, that if you do both like qualitative research and ask users what they think or what they like, and then you measure their performance, the results are not correlating at all in many cases. Yes. And the last thing before we move to the education was once again some crazy stuff, and this time it was not parachuting or paragliding but ultralighting, because I didn't try yet the ultralight, so why not? And in this case we tried augmented reality, because with virtual reality it will really not work because the pilot needs to see the surroundings. But the idea was to give the pilot of ultralight augmented reality glasses and present on the glasses the essential informations they need during the flight, because in ultralight is the same as in car, and that's the reason why they are putting this augmented reality display in the cars, because you are either looking on the road or on the surrounding terrains, or you are looking on all these things things. But you are not able to do both of the stuff. And when you are looking, for example, on your speed or how many kilometers you drive, for too long, which means like half a second, a lot of stuff could happen on the road before you. So it's quite dangerous. So that was our reasoning why to try to put the essential data on the glasses, so pilot can always see what he needs to see whenever he's actually looking. In this case, the main limitation was the display itself, because as I mentioned before, these AR glasses, the current generation, is still not so, let's say, usable as VR headsets. So for example, the device we used has the resolution of 500 by 500 pixels, which in these days sounds like funny. And the real size of the display was 2 by 1 centimeter or something like that. And of course the environment, because it's pilot, so he's piloting outside with direct sunlight and vibrations from the plane and so on and so on. But yeah, we had some work in progress results, and pilots like this idea. They reported it, that it's a huge potential of the technology. Anyway, we know that because the pilots of military are using this technology for like decades, but it costs like 1,000 times more. We try to use like low-end devices, which basically like the headset which the pilot of the some military jet is using. The headset itself costs much more than the ultralight itself, like the whole plane. So it's not really usable. And yeah, we found out that pilots like it, but the current generation was not usable. The most surprising fact was that the device, the AR device, even it was not computing almost anything. It was heating so much that after like 20 minutes, the pilot like says it's not pleasant anymore to have it on the head. Okay, and because I'm out of time also. No. Okay. We have still, but this is shorter part about education using VR. Once again, it's nothing new because just recently I found out one paper which basically is like state-of-the-art review stating 10 years review of educational virtual environments, and it was released in 2009, where there was no actually like usable virtual reality display. So it's interesting that they did this kind of research even without like any working technology. But yeah, there was some working technology, but not in case as we are using it now. But anyway, today, or the common principle we are using here is that, or in any teaching, that if there is high enough engagement of the students, or higher engagement leads to the better memorability. Sorry, it's known for like the centuries, but yeah, it's true. On the other hand, the common expectation is that the high immersion of virtual reality will lead to the higher engagement, because why not? It sounds logical. The question is if it's true or it's just an expectation. So, once again, we did some experiment. This was in 2018 actually. And for reasons unknown, we selected this contour lines experiment in VR. Basically, contour lines in Czech is vrstevnice, like these lines on the terrain, which all the points on the line have the same altitude. I think that there's some image which will be not visible anyway. And this is like this is the mostly commonly used image in some guidelines and lecture books and something. And each time I see what's wrong with the image. And if you're looking enough for it, you will realize what's happening. But for me, it's wrong and weird. But anyway, and we thought, okay, let's try these contour lines in VR. So that was the time when we built the first iteration of our like virtual environment, and not just virtual environment, but collaborative, which means that more users can actually like share the same space and interact with each other and so on. So there is a video. I think this is from 2018 or 19. It looks super old. And you can notice our super simplified avatars, because there was obviously no time to implement better avatars, because always there was a better thing to implement. And surprisingly, we are using the exact same model until today of the avatars. And one reason is that we still don't have time to do the better avatars. But the second reason is that nobody ever complains about like the avatar is bad, which was another surprising finding, because like the realism of avatar in this case doesn't even matter. And now you can see that they are solving some task which is not interesting. Of course, they can communicate through the voice, and now they are happy because they solve it, and so on and so on. And these are these contour lines, and this is the real task, because the first was just the training task. And by the way, this was the moment when we realized the pitfall of VR with small resolution, because on classical map you can actually read these small numbers, but in VR, because the resolution is limited, you actually really like have to move as in this case to read the numbers, So then we were afraid that users will kill us because they like have to move at all. And they reported, yeah, that was nice, I was moving, it's nice experience. So yeah. So this was the first task we tried with the students as our participants. And the result was that, the students were quite happy to use this collaborative environment. They pretty easily learned what to do and how to do, because it was just grabbing and pushing some buttons. And what was more important, they were quite fast to learn about or understand the concept of contour lines in VR, because there was like both 2D representation and 3D representation of terrain. They can flip it and so on. And at the same time, they reported it was fun, so we hope that for this higher engagement and higher memorability concept. And yeah, some secondary findings, as I mentioned already, the avatars are not the issue, and if you even notice, there was some like crude environment around the users, and that's not issue at all. Again, because they are focused so much on the task that they are not like appreciating the texture of the wall or something like that. What was more like serious was the lack or very limited non-verbal communication, and we are still heavily discussing it with our colleagues what to do and how to do, or what's the influence of this like limited non-verbal communication in the teaching process, because obviously you cannot see the face. You can see only where the people are looking or like their hand gestures, but that's all. And we are still discussing if like this is how important part of the learning process or teaching process this is. Okay, so based on this rather like positive experience, we decided to go a little bit higher, and in 2000 I think 18 or 19, 18. We applied for much larger grant, and we didn't receive it. So next year we applied again, and we received it. And this was still before COVID. And in a few slides I will tell you why. And this larger project was once again like the goal of the project was to develop and provide some means for education in VR. But not just from the software point of view, not just developing this platform or framework or however we will call it, but also because this is quite multidisciplinary research, to provide really like accredited curriculum, how to use the VR for education, to provide set of lectures which make sense in VR, and the guidelines for teachers and so on and so on. In the same time, we planned, and now we are using this platform for a lot of research about efficiency of education, but also about interactions in VR, in collaborative environment, but also, for example, for visualization technique, as we heard something about visualization today already. Okay, small detour. As I mentioned, we applied the grant even before COVID. And when we told these guys who are like deciding these grants that we want to do the teaching in VR, they says, yeah, that's nonsense. Like, why you want to do it in VR? Next year, they tell us almost the same, but for some reason they give us the money, which was nice. And then the COVID started. And when we presented our first like some preliminary results during the COVID period, everybody says, yeah, that's awesome that you are doing VR, and because it's needed and it's very like popular. And says, yeah, we are doing it for 3 years already. So yeah, that was interesting. But anyway, when we was preparing this proposal, we of course did quite a detailed like related work review, and we find out that there is not much both university or like research groups or even industry working on VR for education. But once we got this project, once we started and COVID started, and we did this related work review again, we find out that there is a lot of groups doing research in VR and education because it's needed, and now suddenly it looks like promising and useful. But on the other hand, in the same time, we find out that this education in VR, as was presented in this industry sector, was the same basically story as happened for Zoom and MS Teams and all of this stuff, all of these platforms or tools which started as a basically tool for collaboration or some social something, and then from like day to day they became tools for education. But they were not designed as a tool for education. So if you were either both students or teachers, you know how like painful was using these tools for at least the first 2 semesters during the COVID, because they were not ready for it, because they were not designed for education in VR. And for education at all. And in VR it was the same, all of the stuff, because the Google released something, and a lot of other companies released something for education in VR, but it was the same story. It was like just social VR platform banded to education. And that was the good signal for us, because we are really focusing on the education from the start, that maybe we are doing it hopefully right. So now really quickly about the software, it has a really long name, as could be seen here, so we made this super ugly shortcut, and then we shortcut even the shortcut, so we call it eDive, which is completely wrong, because it doesn't tell you anything, and once again there is this diving into it. It was not my call, yeah, and I'm like for half trying to convince my colleagues we really need to change it, but they refuse because they like it so much. Anyway, so it's a software platform based on Unity engine, because why not? It's server-based client-server architecture, so we have server which handles anything, and multiple clients, both students and teachers can connect to the same server and do this teaching there. With different roles, so teacher can have some, for example, button which is not available to students in virtual environment. And from the beginning it was designed as a modular approach, so we can design like different virtual environments where these lessons will be happening, and so on. And which is also important, we are not supporting only VR builds like for the Oculus Quest, which we are using most, or HTC Vive, but we can do the build for the desktop, for example, for the second teacher or somebody who is basically just watching what's happening in the VR, making notes or something like that. Yeah, and actually there is not much need to making notes, because it's a research project, so we are basically logging everything, every movement of the user, every all voice communication, and every touch of the button, and then the colleagues are analyzing basically to learn how the teaching works in VR. From the education point of view, as I mentioned, we believe that this higher engagement will lead for better memorability. And we choose 2 like different paths of the learning. One is this cartography lesson, which we have some experience, and it shows that it's good for VR, because you have 2D maps, 3D models, and actually the process of reading the map or some data on the map is quite interesting and not so easy for students. And the second stuff is English actually lessons, because we are not the English was not primary language for most of us, I believe, here, obviously for me. And then we find out it's for this VR again is quite nice, because one fact we find out that these role-playing games are fun again, and by role-playing games mean that if you remember your high school or elementary school, and teacher says, okay, you will be the customer and you will be the cashier, and now play the story about how you are buying 10 bananas or whatsoever. And everybody hate it. In VR, not everybody hate it. Actually, most of our participants like it, because you can actually put them into the supermarket. You can actually put this grocery around, and if they are bored enough, they can grab it and throw it away or do whatever they want. But the VR like stimulate the discussion and make this kind of teaching much more fun again. As well as for example, prepositions, that something is lying on something, or I don't know, painting is hanging on the wall and things like that. We have some environment precisely for that, which once again supports the discussion, and it should like enforce or improve the learning. So yeah, by now the system is still in development. We have really like working backend, this server part and whatsoever, and we have already 5 teaching lessons in different virtual environments. Most of them was already tested with some university students, and actually there is a large user study in progress with I think like 40 or 60 even students of our university, and so far feedback is positive, but yeah, we don't have any data like crunched to the end. And as I mentioned, this is like most interdisciplinary research we did because without like beside the software development, we are working with psychology guys for like a lot of stuff. We are working with education guy, how to design these lessons in VR. We are working with domain experts, for example, with cartography and much more, which is like quite interesting on the one hand for the research point of view. On the other hand, our basically maybe biggest issue is communication, because I'm not able to translate it, but the Czech saying I'm nemluvím jazykem vašeho kmene. I'm not speaking the same language with you, as you. Is definitely true with in this case, because psychology guys not just think differently, but they if you are talking about something, they tell us, okay, we need this we need this and that. We implement it, show them, and yeah, we want something completely different. Yeah, but we did exactly as we understand what they want. So and this is happening again and again. So yeah. So this is just some image of funny environment where you just can grab some objects and move them around. And this should be video. Yeah, in progress. Yeah, there is some low frame rate, but never mind. This is manipulation of the object, and this is the scenario where the user is told to like basically furnish the house, so he can select from a lot of furniture and discuss with the others. Okay, we should place this super nice comfy chair into the kitchen because it doesn't make any sense at all. And as you notice, they can even make it larger because we discuss how like they are able to grab this 2 meter high like cabinet and go through the wall. So we make this trick that they can press the button and it will squeeze to like 10 centimeters. They can walk like comfortably and then enlarge it again and place it, and of course discuss it and so on. We even tried to do something more realistically or visually more interesting. And in this environment, we have even global illumination guys, but definitely it's not real time. It's obviously pre-computed, and just light maps for this makes out of I think 90% of like memory budget. But yeah, it doesn't look so bad. And once again, it's for English lessons. So this is actually the village just near from the Brno, with some superficial like colored objects. With some story behind it and so on. So yeah, once again, students are supposed to go through the villa, explore it, and then talk each other about it, what they learned, and what was the history of the villa, and so on. And the real last few images, as I mentioned, we are also trying some visualization techniques. So once again, cartography, some maps, and some stuff. And the task here was to show some data on the map. I will not go to the details. And they provide us we want to represent the data in this way with these colorful like bars and whatsoever. And our group of visualization experts says, yeah, that's nonsense. It will not work. And we ask, okay, so how we should visualize the same data? And they tell us, okay, use this kind of like bar charts or whatsoever, or use this kind of pie charts. But I says, yeah, it's in VR. Okay, will it work in VR? So I says, yeah, let's try. So once again, this was, I think, diploma thesis, where the student implemented not just the virtual environment, but like 3 different like visualization technique of the same data. And then we actually compared like which visualization is more readable or like understandable for common people, not like interested in the data at all. And yeah, the results was completely surprising again. I will skip that and just take home summary. Extended reality, even AR, VR, whatsoever, reality is nowadays at consumer level available. You can go to the shop and buy very decent like headset for a few bucks. And from the research point of view, there is a lot of hopefully interesting for you, or at least for me, fields of the research which are rather unexplored because these devices really appeared a few years back, so there is a lot of new stuff to explore and research, in both in like basic research and the applied research we are doing. And from education, I hope or it shows that it could be a very useful tool if it's well prepared and well used correctly, which goes surprisingly far beyond just software implementation as we find out. And that's all. Thanks for attention.
Thank you very much for this very inspiring talk. I believe there is a lot we are interested about now. So I believe we promised to be flexible, so we will have to make some time for questions. Okay? So go ahead.
You tell us that there is not a correlation between this qualitative research and user experience, or when you are having interviews with the users. So do you have some hypothesis why this is so?
I have many hypotheses. One is more crazy than another, and none of these are in any way proved. But I think it's similar kind of problem as, for example, in so-called usable security, because in any system could be either secure or usable, but not in the same time. And in VR, users tend to select these usable solutions, although they are not secure or not usable efficient. So we tend to select the solution which is more common for us or more convenient, even though it's not so efficient as the hard data can tell. Or if you try for a few times, you will learn that even if it looks weird, it works well. But yeah, you will tell it looks weird, I will not use it. So, but yeah, that's just an idea. We didn't did any research to address this specific question so far.
For this archaeological assembly task, did you analyze this in more detail? For example, how much time they spent for the coarse assembly and then the fine-tuning compared from desktop to VR?
No, we didn't compare these specific times because different users use different approaches. Some of them were not using this fine-tunes almost at all. They were relying just on bare hands and this coarse movement, and still were able to set it precisely, while others really put it in the coarse manner and then play with the axis, because they were more used to tools like Blender. So once again they used their learned workflow. What we did, we measured just the time, time of completeness, but we check the precision of the result. So we have some ground truth, and we measure distance of each piece from the ground truth to be sure that not to claim okay VR is faster but much less precise. That we want to avoid this and they were instructed to make it as precise as possible. But yeah, we didn't measure in details this interaction times. That will be interesting.
Also measured over time, the accuracy over time.
That's also not so simple, because some users when they put third piece or fourth piece, they put it and place it very precisely. And then grab another piece, put it roughly, and then precisely. But some others first assemble everything and then iteratively increase the precision. So they use different workflows, which is kind of if we do the study with 100 students, maybe we could get there. But I'm not sure if there is 100 of students of archaeology in Brno at all. Probably not. Okay. Thanks for the question.
Is there any research on using VR or AR for teaching at university? And do you think it's plausible to use AR and VR at the university level?
Definitely yes, because our system actually was used during the last semester at the university. During the one course, basically almost the whole course was taught in the VR. And a few weeks ago we were a little bit disappointed not to be first, because we found out that the Stanford University make some statement that they have some courses completely taught in VR. But once again, they are just like gathering in VR and discussing in VR without no interaction, without no like extra functionality designed for education. They are using just VR instead of MS Teams. So, but I think there are like 4 or 5 universities in Europe that are like seriously involving VR in education.
So you were speaking about writing under the water.
Mm-hmm.
And how is it with writing with the e-learning in VR, especially with little kids, which I think it's gonna be useful even in future to know how to write by hand.
Yes. We are not addressing little kids for many reasons. So we are working with high school students or university students, and
Or
yes.
if you take the little kids out of the current
Mm-hmm.
equation, let's say learning a new language,
Mm-hmm.
we can do that with adult people, but they also need to write something. And
Yes.
Is that how do you solve that writing?
Yes, that's great question. How to deal with making notes or writing something in VR, and it's really hard. And we spent several bachelor theses on this. Several students try to different approach. Because you can design some like writing, handwriting. You basically held some piece of paper whatsoever, and you write with your hand. But with current generation VR, the precision is like one magnitude lower than when you are writing with the pen. So if you are holding like A4 piece of paper, you are able to write like 2 words on it, not more, because it's not so unprecise. So now we are still thinking how to improve that. So far we are using audio notes. So you can just press a button, record some short audio notice, and then after, like when you are out of VR, you can like rewrite it from audio to your notes. Which is far from perfect. On the other hand, because you are doing it again, you will memorize it more. But yeah, for like really writing any longer text, we don't have sufficient or good enough solution so far. But yeah, it's a huge problem.
What about haptic feedback?
Keyboard. Yeah. Once again, with current generation, it's not possible because, for example, if with Oculus Quest you are holding the controllers in your hands, so you cannot just release them and use the keyboard. And with the virtual keyboard, basically the only feedback you can have is a vibration. So imagine that you have like virtual keyboard here, and when you are trying to press the button, when you like pass through it, you just feel the vibration, and that's all. And it's really not satisfactory. We even tried some like specific keyboards for VR, similar to something as was how it was called, Key 9 for mobile phone. When you just write for a few letters and they will like try to like, or it's used even now, like they will offer you few words so that could be useful. It's faster, but still it's not as usable or as fluent as we want. But yeah, we are still trying new stuff here and trying to find some good solution. Yeah.
I have a question about the costs for the students, because especially in the COVID pandemic, everybody was isolated at home, so there was no way to get them a VR headset, I guess, or
There was. You can just borrow them. Yeah.
So you have enough headsets that you can give out to the whole class and
Yes, the trick is that the class is small, because in VR you cannot handle the class of 30 people, so it's the education is more like personalized, and you have smaller class, and you need, as a teacher, you need to spend like 2 times or 3 times more time because you are teaching the same class 3 times. But yeah, we are doing it exactly that way, that we bought I don't know, like 20 headsets, and we are borrowing it to the students to the home, so they can work with it.
You have said that you tried the underwater keyboard in the public pool, I
Yes.
guess through Žánky.
Yes.
It's like
No, it was on Kravihora.
Yeah, but still it's like 5 meters. Have you tried even deeper? Because in my experience with the depth, my cognitive ability just goes away, sometimes even the short-term memory. Is there some... It's really a thing. It's research that you are losing your short-term memory.
It's a really thing. It's very dangerous and hard thing, and that was the reason why we didn't try any deeper, because once we need to go abroad, because in Czech Republic you don't have any sea, or you can go to some pool, but or not pool, rybník, whatever. But we tried actually not even in 5 meters. We use like 2 meters depth, because not of the participants were actually like skilled divers. So yeah, and actually the intended usage is not for such huge depths where you are not even like thinking about taking your mobile phone in the. But actually, yeah, when they are doing, for example, this archaeology underwater, it's usually in shallow waters, like these 5 to 10 meters, and then in these depths, these like cognition problems are not so severe, and in the same time you can spend much more time underwater in one row, because so the more the depth you are diving, the shorter time you have. So yeah, that's it. But yeah, with the pool it was really shallow water.
I wanted to ask you if you ever made an experiment where you would follow how people adapt to the VR and over, I don't know, over a year or over 2 years, and no?
But yeah, continue.
The question is if you ever notice people getting better at stuff in VR, and what are the things they keep getting better usually?
We didn't done any like longitudinal user study because it's super expensive, and we are still developing the software. So now actually we can start the study, and it will take us another 3 years, and I'm not sure if we have a budget for that. And so yeah, it's pain in all aspects you can imagine. And getting better, there is a little bit different point of view, and that's from the developer point of view, because we are developing VR for the years. And I know many guys who are developing games in VR for many years. And the thing is that actually people get something as an allergic for VR. Because imagine that you are developing VR game which is not working at all, like it's lagging, it looks ugly, and you are testing it for 8 hours per day. And your brain basically gets so like sick of it that another day or after a month or after a year you even like see the headsets and you feel dizzy. And I know really guys who have to left like VR development at all because they were not able to put it on their head again, because they were so like sick of the VR after the time. So actually you are not getting better, you are getting worse after time. If you are doing like development and testing the stuff which is not properly developed and so on. So yeah. Maybe the last question.
Last question, okay.
I think you can get allergic to pretty much anything if you do it for a long time. But my question is regarding the sharing of the devices. I guess you're using Quest 2 from Oculus.
Yes.
And I want to ask, like, how do you solve the problem of sharing accounts? Because I think the agreement from Meta or Facebook is that you need to use your personal Facebook account to log in with the device. So do you use some fake accounts? Or
Do you want like official answer or? The only official way so far is really to force each student to use their own Facebook account and to make a factory reset for each after each usage, which is really painful.
Yeah, okay, so I guess that's an answer enough. And a second quick question regarding the small children and really anyone who is not adult yet. There is quite a topic if this VR headset, current generation of VR headset, cannot somehow harm the visual system of someone who is not adult yet. I think the general agreement is that anyone below age of 13 should not use VR headsets. So are you discussing with some doctors or any experience with this?
That's one of the many reasons why we are not using or working with anybody under 13 or whatsoever, because it's forbidden by some rules. And with this like harmful for human vision, I think it's the same as with the television, mobile phone, and everything else. Like there is always these discussions if almost everybody believes that the over usage of television is harmful, like especially for kids. But like to what degree or what is like recommended number of hours per day or per week, nobody is able to tell you. Even the doctors, even after like years of these studies. And with the VR is the same. So yeah, we are trying to design our experience like rather shorter than larger. Usually like the lesson is like 40 minutes max, but usually like if you are doing some experiments, it's like about 20 minutes, which we know that it's okay for the people. They are not reporting motion sickness, they are not reporting like eye fatigue or something like that. But yeah, we are, I think, missing hard data, and that's for another kind of research. Like, and it will be quite hard to prove or disprove any this like consensus. Yeah.
I have just one very short remark. Actually, like these headsets are now using for the eye treatment when you have when your brain is actually trying to like shut one eye down. It's called tupozrakost. Tupozrakost. I don't know the.
No idea how to say it in English.
Really don't know. Sorry, but it's like when your brain just shut one eye down, and they are using the Oculus headset to fix it somehow also in small children. So they are. You need to have both eyes cooperating on the some job, some task. Yeah, thank you. And so you have to use both eyes. So they are using it for kids. Actually, I know about. There is harmful.
Yeah, it was harmful in like depth perception. If your system is not like developed enough, then it's believed that it can harm you, and you will be basically you will not be able to focus.
Okay, so but they are still using it for treatment.
Yeah, that's weird.
No, okay.
Okay, well, thank you very much. Would you like to react?
Not really. Or we can discuss it afterwards.
Very good discussion. We will have to continue asking questions in the break. I'm sure I have some questions myself.
Asi značku jedničku vytáhneš, hodně sem. Asi můžeme
Good job. Oh yeah, I did.
Sugar. Asi je to tu.
Teraz jdem ako ja.
Dobre. Dobre, tak sa ďakujem.
Určitě, mají Martin na toto dobu, že buď od něj, já mu klidně řeknu, ať jako to, anebo si no určitě. Jo. Vždycky jsem jako vždycky zapomněl, mám jich na stole asi takový, že jsem vždycky si dovezu sebou, takže nemám co rozdávat, ale jo, podle jména, jsem jako dodatelný, ale prostě jsou nějaké věci. Jo, to ano, jo, tam jo.
Po slovensku, že?
Áno. Máme to niekomu uložiť?
Áno, tam je to vložka, že presentation.
Už si môžete aj vyložiť potom poster tu.
Hej, na tú vlastne.
Tu si nadá z nejakých aj jedno alebo druhú.
Čiže na ploche to je tá vložka.
Hej, ale nenačítalo to.
Nie je tam na stolu, že niečo strík. Tak
že proste, že človek sa, ale tak tam je trošku iná situácia, nie je to veľký screen, že proste, že človek aj tak vlastne, keď to tam skúšali nejaký úder, ale ono je to veľmi
efektívne videnie názory, že nejakým pár stupňov.
že ľudia to ako keby vnímali, že reálne videli ten rozsah, že oni si na to aj nebudú myslieť.
To sme nedělali my, to jsem asi neřekl, to jsme
To nebolo úplne jasné.
A tracking sa to používa, ale
pokus, teda, že sa renderuje
jasne.
To áno, dáva zmysel, že to renderuješ kvalitne a to ostatné nie, ale to bol vyslovene ten fokus. To je taká, akože či to má dodať niečo,
To není jenom optimalizační, to může být i jako ten beautification effect, protože pokud
Michala budete obvykle prezentovať, striedať sa budete nejako, áno? Povedali mi, že na vás mám 7 minút v tej sešni, viete o tom?
Bolo naplné 7 až 10, môžeme sa pokusť.
Dobre, tak 10 skúsme.
To stihneme určite.
Áno, dobre.
Aj tých 7 by to mohlo byť.
ale vlastně, že vyloženě jako tu čečku vždycky
Je to tam, hej? Keď to
ten fokus určitě otevří a podle toho vlastně mluví scénu. A to je jako celkem jako heavy research, no, to jsem uváděl, že to, ale spíš že potom vlastně nás schopná narvat do toho headsetu a ten s těma jako liquid crystal lensy jsou určitě strašně
je nepříjemné, to se mi vůbec nepáči.
Ale asi jako realizace nebude tak jednoduchá, ale zase to posouvá vlastně jako někam úplně jinam a dává to i nám vlastně úplně nový jako...
A teraz už je to dobré?
Protože jenom se ten fokus není tak snadné, že člověk jako nemůže jenom tak jako předat, jako může, no, ale to úplně no, takže tam ještě
Položil tu quest a nemám pocit, že to tam potreboval.
Jo. V tom questu ani ne, ale to vlastně musím zvyklý, ale já jsem asi pamatuju, kdy byly ještě jako training 3D filmy a 3D televizi, což jako tak jako, to je taková ta aktualita, já. Když jsem byl v kině na nějakém, to bylo Avatarovém, mě strašně vadilo, že přestože to je 3D, tak já nemůžu si fokusnout. A vyloženě v tom kině mi to nadsfaklo, že tam ty, ale v filmu mi to nikdy nevadilo, že bych jako ostří ten kamerama a tady jako já bych chtěl zaostřit někam jinam, ale nejde to. A pak mi to vadilo a...
tak zase v kíne sa to asi dalo, to bolo veľmi ťažké vyriešiť.
No, každého jedného. Multi-user to ještě jako, ještě mega, ale ten VR tím, že to je pro jednoho člověka, tak tam to všechno kalibruje.
Ja som teraz mal študentku, ktorá mala problém s tým, že keď si dala headset, tak mala stále ho rozostreniť. A potom sme vyslovene riešili to, že existuje na webe aj taká aplikácia, ktorá akože simuluje rôzne rozostrenie traku alebo aj rôzne ďalšie poruchy. A tam sme zistili, že presne, že čo to je, hej. Ale nepodarilo sa nám to vyriešiť tak, aby ona bola schopná.
Dalo sa to prerenderovať tak, aby to akože videla.
Vieš čo, to je ťažké, lebo tam tie poruchy môžu byť rôzne typy.
Ona to nemala diagnostikované, že nevedela, že čo.
Niečo mala, niečo sme tušili, že asi bude to.
Lebo viem, že to som tiež videla taký paper, kde toto práve riešili, že proste podľa tých rôznych bát, že vedeli prerenderovať tú scénu.
Ale keď prerenderuješ tú scénu, nie vždy si schopná sa trafiť do scény. A tá vada môže byť taká, že počas toho pozorovania tej scény, takže sa to mení rôzne, hej, že nemôžeš to stabilne renderovať nejakým spôsobom.
A ešte som mala jednu vec, že vlastne že sú teda paper, kde skladali, že mali úlomky vás a potom robili nejaké či toto je nejaký systém, ktorý to robí s tými holstrami napríklad s tými holstrami a ste na to či by to dávalo zmysel, že tam aspoň nejaký estimate, ako by to vyzeralo, to vlastne oni iba robili ten fan.
S tou, jo, nemám to až na spoustu lidí, protože to nedělají asi automaticky jako assembly, jakože přece jako to. A problém u těch archeologických věcí je, že oni jsou po těch 300 letech natolik šoupané, že oni vlastně k sobě nesedí. Takže tam jsem ty dva kusy autonomity na sobě, tak se člověk snaží se blít, tak oni nesednou přesně k sobě. Takže tam jako musí být ta expertní znalost.
We saw her biking. I was very jealous.
Máme nejaký model, toto boli vázy, historicky, ktoré vykupovali tiež ako
U těch vás to může asi být, no. A navíc třeba tam ještě si mi potom zjistili až zpětně, že kompletně tomu bylo, když jsem měl s tou lepkou, tak ta lepka ležela někde v Brně na místě, kde ještě jezdila tramvaj. Takže to bylo ještě jako kompres a byla celá jako zdeformovaná. Takže každý měl vlastně jako trošku nedeformovaný, takže nešlo složit, že ten gram stůl jako perfektní, aby tam nějaký díry.
Na nur dich informieren, also dass er beim IPC-Meeting Hybrid dabei sein wird.
Achso, ja.
Genau.
Hast du die Liste gefunden, die du wolltest?
Bitte?
Hast du die Liste gefunden, die du wolltest?
Erst alleine und dann kommt Daniel. Das heißt, heute will ich den Zimmer einfach freilassen. Und
nehme ich das.
musst du das?
Ja, weil das ist ja, ist das nicht.
Und warst du schon in 33?
Nein, das war noch, ich habe nur kurz einmal aufgestellt und geschaut, aber ich war nicht.
Ja, okay, dann kann man es noch tauschen. Ja, dann machen wir es so. Das wird das Tauschen und dann bist du hier alleine und dann, aber na, das ist ein bisschen blöd, weil sonst würde ich das eigentlich so machen, dass ich hier auch den David Hahn morgen geben würde und ich würde eigentlich dieses Zimmer sparen, die 80 €. Das ist 20 € Unterschied. Ja. Wenn ich da Uni verrechnen kann, ist es mir wurscht.
Achso, weil das ein Einzelzimmer ist. So.
Ja, er ist auf Doppelzimmer alleine, weil das war ziemlich schlecht, das irgendwie alles heute.
Wir sind nur Doppelzimmer.
Also du bist Einzelzimmer, du wolltest Einzelzimmer, du könntest auch im Doppelzimmer sein. Und dann haben wir morgen den David wahrscheinlich hier. Den 39 oder den 33 sogar würde ich ihm geben. Den 39 haben wir dann frei, die ganze Zeit lang. Hier auf dem zweiten Stock Richtung Tenaba Ausblick. Also die Entfernung, ja, die ist sehr gut bei 22. Aber all die Einzelzimmer sind hier drüben, wo du bist. Deshalb, ja, kann man es machen. Diana, so Michi will check the 22 because Daniel Cornell should have arrived today, but his colleague in the office tested positive, so he will not ready to come. Maybe Michi would take that room instead.
I have 3 keys.
Okay, let's go downstairs.
To jsme řešili jako úplně vyšácku. To nám nevím, my jsme jako první asi týden, jsme neměli ten headset, my jsme jenom to jsou vlastně 2 koule, ale jenom jako deformované. A okamžitě jsme si uvědomili, že to, že není vidět, kam se dívá, tak je jako problém. Já když tam mám nějaké oči, mám tam kretenský, že to prostě nevíš, že když tam dáme cokoliv, to dá blbě, co tam dáme. Když mám ten headset prostě, to jsme náhodou měli ten model, když jsme tam headset a najednou začalo fungovat, protože nemusím vidět oči, které jsou strašně triky, ale zároveň vlastně podle toho jako vidím, kam se to člověk dívá a mám to orientaci, a to je pro mě strašně důležité. Třeba od toho stranu člověk komunikují, takže kdo se dívá na mě, kdo se dívá na stůl. A funguje externí věc, že taky ten laser pointer. To je také jako jednoduchá věc a tak jako to, že prostě když potřebuje, tak podívej se sem, co ten laser pointer ukáže. To funguje jako externí věc. No.
Ešte mňa zaujala ešte ten haptický feedback, že ja som to pred pár rokmi mala, že som s ním mal taký research celo, že revel, neviem, či to je podobné. To bolo založené na tom, že teda tiež dávali tam nejakú reakciu zápestia a reakciu. Že tiež mi to prišlo na prvú také zvláštne, že prečo to nebo zápestia, ale hej, že proste s vámi sú také, že...
Že jako pokud si skutečně ten feedback, jako že může něco chytit jako ten podpor, že se může třeba o něco opřít, nebo to nejde skoro vůbec, tam je jako jiný způsob, jako měl to virtuální země, kterou se může opřít, tak jako zatím je ten ultrasound, a ten musí dát silnější, což se může být asi ale to, že třeba můžou chytit něco, prostě a cítit to, tak vlastně jediný způsob je skutečně vlastně mít nějaký exoskelet, který dokáže se vlastně takže s tím tohle to nikdo nechce ani používat, ani chytit, protože tam jako klasicky žádný vývojář jako nedá navrhnout něco, co může ten prostě rozhodnutí zlomit, že? A pak proto programoval ten software, to jako je málo kdo.
Teraz to už zkoušet ty 8 hodin denně jako.
Takže my máme jako
to už ani
že svého času byly strašně populární VR kolekce, no třeba i jenom ty jako vlastně, které měřili, to byl nějaký metalový projekt, který měřil vlastně ohyb prstů. A pak se to přestalo používat, protože to jako nechutné, že jo. Ale teďka zase nová generace. Celý motion to hodně posunul.
Motion je poctivá veľmi taká malá krabička, ktorá má v podstate infračervený projektor v ekrane
a coffee and
so you have the filters.
Yeah, I went there. I applied for student volunteering, and then I virtual, so I might be surprised to meet volunteers to speak for about and I found out I wasn't prepared for ex-students to join the student volunteer program because of the COVID.
A fakt teraz fotíme ty
Tak jako, tak se vrátí na ty
Ladies and gentlemen,
Just trying everything.
Next session.
Díky, jak to si ještě určitě vzpomínala, dobrý, každou jsem se snažila si to tak zapomnět, lebo nemám papír, že jsem číslo nedělala.
Let me remind that you will be voting for the best presentation. Don't forget the speakers and their contributions. Please don't speak with your friends, with your local friends in your local language. Network, please.
Yes, speak Czech, not Slovak.
Next, up to now, we have multiple professors like Hauser, Beneš. Beneš is the guy with the invisible virtual nose. Zanner or Wimmer, who started at CESCG. But for the first time, here we have the dean who started at CESCG. Jan Lacko, the dean of the Faculty of Informatics at Pan-European University. And the first speaker from this university, where there is probably the best virtual reality lab in Slovakia, will be Martin Piliar. And the previous invited talk was an excellent introduction to this session, because this session is on virtual reality, augmented reality, mixed reality and perception, which is overmixed with all of them. As Andy Warhol told, everybody has 15 minutes of fame. Martin, the floor is yours.
Which one again? Alright, hello, I'm Piliar from Pan-European University. I'm finishing my master's degree, well, hopefully, with my thesis about collaborative use of the virtual and augmented reality in selected domains. And today I want to present to you our implementation between those two devices. But first, let me tell you about some use cases and why should we even do something like this. As the previous presentation has shown, if you remember the blank video, my colleague told that you cannot see all the immersion in the 2D screen, and the world is much more immersive in the VR, but well, we are stuck in the 2D with the 2D screen. So what should we do with this problem? Well, there are some use cases where the external observer needs to be immersed with the virtual reality the person wearing the virtual reality, and immerse the virtual world at the same time, but they need to see the real person too, their emotions or movement or whatever they need. And as I was saying, the virtual reality is immersive just only for the user wearing the device. And if you look at, for example, two virtual reality devices, let's just say two people playing a multiplayer game, they can see their virtual avatars. They
their positions of hands and the headset is approximated in the virtual world, but they cannot see each other in the real world. They cannot see their emotions. They cannot see who's talking or anything more complex. And they are stuck most of the time just with this virtual to virtual reality device or a virtual reality device combined with a 2D screen, and with this approach you cannot align the virtual objects with the real positions like hands in the virtual world, and many times what you see in the display it's mirrored, and well, you are not experiencing what they are experiencing. So for this we developed a platform. Well, no, the platform itself has almost no use in the real world because it's just a connection and just a backend for the technology for the connection. So we developed a demo application called PhysioGo, which is used for physiotherapy. Well, the let's just say mini games have no physiotherapy. It's just a demonstration. Let's just say one of the possible use cases. So, and the proposed solution is two separate applications. Yes, I am allergic to VR and AR at the same time, so bonus points, I guess. With one companion application, external. For the mixed reality devices, we can use, well, Microsoft HoloLens or Magic Leap or any commercially available device, even smartphone, but that's the 2D screen problem again. So that's not very usable. And since we don't want to reinvent the wheel with stuff that has been done many times, like networking and authentication of users and so on, we are using commercially available software, so we can better scale the application and reduce the development time. The platform is developed primarily for Microsoft HoloLens, even though we made the system itself abstract enough so that we can easily swap the device-specific SDKs for another, like swapping mixed reality toolkit to Magic Leap SDK or something else. And in terms of the software, we are using Unity engine for both of the virtual and augmented reality devices. For the Microsoft HoloLens, we are using the Microsoft HoloLens toolkit, which is an SDK package which provides us with the spatial mapping and all sorts of fancy stuff, and that we can use since we can use multiple vendors for the VR devices. We are using the OpenVR SDK that provides us a standard API that is supported by multiple devices. For the network connection, we are using the Photon network or Photon engine, which gives us a quick synchronization between the physics objects, and we can send multiple RPC messages, and we don't have to develop our own, let's just say, WebSocket solution or something else. And lastly, for the image tracking, we are using Vuforia engine because it allows us to quickly scan images and their nature features. Using commercially available software has enabled us to quickly develop the platform without any need to spend time for something that was already developed, like I said, for the authentication, databases and so on. Which brings us to another problem, that many of the softwares can be very quickly discontinued, and we are stuck with something that's not working. But that's just a possible scenario. That's not a real problem. The center point itself is being scanned by the Vuforia engine. We are using a pre-generated AR marker, as you can see on the small GIF on the right side. When we scan the marker, a invisible object is spawned at the center position, center world position in the Unity engine, which acts like as a parent to all the visible objects to the user. All those visible objects are then aligned according to the position of the marker. So when we put it wrongly, it will be misaligned. So we have to put it on the ground correctly. And the items itself are waiting to be shown when there is a successful scan made. So there is no random floating objects in the scene. The thing is, I couldn't record a in-device footage, so there is a Unity footage from the application. On the right, on the left GIF, you can see the scan. The scan is made by the Microsoft HoloLens device together with a smartphone. I will show you the process later. Which then, after a successful login, creates a photo network room, which then waits to the second virtual reality device. After a successful connection, a list of possible applications is being shown to the augmented reality user, as can be seen on the right GIF. The application has one demo minigame called Punch It, which is just a demonstration of the spawning and the interaction. This is the same process from the virtual reality user. On the left GIF, you can see that after a successful login, the augmented reality device or the HoloLens sends the data to the virtual reality device. The data in this particular scenario consists of the previous, let's call it physiotherapy sessions, and the user can just look at the data and let's just say analyze it before the game itself starts. And then after the HoloLens user starts the session, the user is being shown a splash screen and the game starts. I've got at least these screenshots, as you can see from the Punch It minigame. On the left side there is the footage from the HoloLens, which has the aligned gloves with the real hands, and together with the punch circles. The right screenshot shows the virtual reality footage. The absence of the particle effect on the second image is not because we didn't implement it, but Microsoft HoloLens has a screenshot delay, and it has been quite difficult to align the footage. But as I was saying before, for the authentication, the user has available a company or application which, well, since we try to work with the Microsoft HoloLens and interact with complex UI and user data, we found out that the user experience is not very great, and writing, let's just say, names was quite long. So we developed a companion application which does the heavy lifting for the HoloLens application. The user can work with the application at the same time as they are wearing the device. The process is simple. Well, I will tell you later on a graph. The application was implemented by Ionic Framework, so that means that you can make a progressive web application or run it in a web browser. So you are not restricted to a mobile phone. You can run it on a computer. We have on our own backend, which is developed in Flask, which is a Python framework, micro framework. And for the database, we are using Google Firebase because it provides us with a quick authentication API and database for storing data. So the workflow is simple. After the user logs into the application, they do whatever they want in the application, and let's just say they pick up the latest patient. After they select it, a QR code is being constructed as being shown on this slide. Oops. On this slide, you can see in the third screen there are the available patients. As the user clicks on the profile, a QR code is being shown to the user. After that, the user scans the QR code with the Microsoft HoloLens, and the QR code itself contains a session token and the user data from the selected user. The session token is being used to ask for the backend for a JVT token, which allows us to connect to the Google Firebase through the augmented reality device. The token itself is valid for about 1 hour, and we can, thanks to it, work with all the data that is provided in the database. Since the device is acting like a master client, let's just say, we can fully manage the data, deleting, adding users, or whatever we need. In conclusion, using the commercially available software was great, but not each piece of software was great to work with, like with Vuforia. It's a great tool for tracking, but the combination with the HoloLens was painful. Like I said, I'm allergic to HoloLens now, and the company application itself is developed just for this demo application, so it doesn't exist in a abstract form like the platform itself. So that would be great to implement, just to make it a whole package. And that's it. Thank you.
5 minutes for questions.
I have a question. What kind of limitations do you have? Like room size or?
Well, since we are using one, let's say, QR code or AR marker, we in terms of the augmented reality device, we don't care about the room size because it has its own inside-out tracking, and the limitation is whatever the virtual reality device gives. Maybe the limitation, at least for now, can be that the application is just for one-on-one. You cannot connect multiple virtual reality devices to one AR device. It's ready to work that way, but it's hard-locked to just work on one-on-one.
Okay, 4 minutes for questions. Maybe I have to notice that your solution is outside of the Chalmers classification of the levels of realism, which can be somehow measured being physical or non-physical, believable or not believable. But how can you measure the quality of cooperation? That's my question.
Well, that's the tricky part, because there still needs to be some more complex tests, and the punch-it application itself is quite, well, you are just throwing punches into the air. So in that case it works pretty well, because the photon engine is even predicting the movement and all sorts of physical stuff. So yeah, in more complex and let's say when you are doing some more miniature movements with the controllers, there still needs to be more research to be done.
Thank you. Zuzana?
I want to ask about the registration using the QR code. So as far as I get it correctly, you have just one QR code posted somewhere, and it has to be seen by both devices?
Well, the QR code, which is being shown in the mobile application, is for the authentication. The AR marker, which is being on the floor, only the HoloLens needs to see. The VR device, the center of the VR device is being shown by the play area. So when you are setting the device like HTC Vive, during the first setup you are making the safe area, which then acts like, which then automatically calculates the center point for the VR device.
Okay, so you have to manually somehow.
Yes, for the first setup, yes.
Registration.
Yes. Yeah.
Okay, so and have you thought about doing it automatically, that you have camera in your VR device as well, so you can see the marker on the floor also by your VR device, and you can do the registration like automatically?
That's one of the possibilities, but I had quite a little problem with that the device itself was the VR device. It was quite fighting with me by recentering the world center. So at least for now, I went with the manual alignment.
Okay, so but then you can't move.
You can move with the even with the AR marker, however you want. You can even move with the VR device however you want, because it acts like the center point. The 000 point of the virtual world is the AR marker for the HoloLens device. And the VR device has the 000 point at the center of the player area.
1 minute.
Well, if you look at, let's say, control scenario, imagine that you place a square with a tape on the floor, and you track the. Let's talk about the HTC Vive setup. You draw a square with the controller to create a player area the same size as is the square on the floor, and
I can get it, but you can't go like anywhere else.
with the VR, you can. You can.
Outside play area.
Well, outside you can. Why would you do that? Because that's the safe area. But yes, if the room allows you, you can. The safe area just calculates the center point, but you can run away and the device will track you.
Okay, the next discussion can continue outside of here. Thank you very much. Professor Sanja is not here, but students from Sarajevo Technical University will present a perceptual aspect of movies. The next speaker is Sanja, Milović, and Bojan. Bojan means the fighter.
Okay. Hello, everyone. So the topic. Oh, yeah. Not used to this, so yeah. Hello, everyone. So the topic of our paper was user perception of camera movement in VR video. So to give quick content, we'll go through a quick introduction, go over the case study, our video sets that we recorded, user experience and results, the conclusion, and what we want to improve in the future. So firstly, Bojan will talk about what camera movement is.
So, hello. I'll take over just for a starting part, because here we talk mostly about
technical stuff, but I'll just introduce it, why camera movement, what is shooting, and etc. from a bit of artistic side. For regular 2D video recording that we are used to, framing is like the way that the director actually guides the movie, guides the attention. In 360 video, that's not possible because everything is now in frame. And the second tool for them is actually camera movement, which we decided to test how it works in 360 environment, because as we saw in VR, motion sickness causes many problems for VR applications, and most of them are still controllable by a user. Now when you're having a 360 video, it's very uncontrollable and can cause even more motion sickness. So what we did, we shot the same video 3 times, and each time we increased the movement that user was experiencing, and then played all 3 videos for the users to see. How we did it, I actually strapped this camera, this is 3760 camera, on my head and walked beside our tutor who was telling a story. So what we also introduced is the shaking of me, walking, me turning around, so all the bad things that you can actually experience. And then we gave it to the users, which will Sanja now present to you.
The first option we recorded was just one static was a set of static videos with teleports. So as Bojan said, he would stand for these static videos. He would just stand in one place and record them in different rooms. Then for the second option is where we started introducing movements, and we also had this teleport. And in the third option, we had just one video with continuous movement, where Bojan was tracking the museum curator through the whole museum. So here we can see the structure of the application we created in order to present these videos to the users. It's a simple application where the user can select the language and then proceeds to select an option. So after viewing each option, the user would be returned to the menu. And now, depending on whether these video sets had these teleports, here denoted as story points, the user would be shown a button, the user would click on it and be teleported back to the next room. So, the research question of our user experience evaluation was the following. So, does the increase in camera movement increase the unwanted side effects of experience, and does this decrease immersion? The experiment we conducted included 21 participants, each engaged by invitation, and we had a balanced demographic features in mind. So the users were of different gender, age, and different level of VR experience. But all of them used the same type of VR headset and watched the videos in the same order. The questionnaire we made was organized in 3 sections. So an introduction with demographic data, a section dedicated to measuring of presence and immersion, experience and behavioral intention. And then lastly, there was a section for open questions, comments, and critiques. So the measurement of the variables of interest was performed using a 5-point Likert scale. We wanted, as I said, to measure 3 things. That is, first, presence and immersion, so how immersed is the user. Second is experience, here meaning the negative side effects of the experience, and third, behavioral intention. So does the user want to continue using this type of application or video? So we hypothesized that users would experience a high level of presence and immersion, a low level of negative effects related to the physical experience, and an intention to continue the use of virtual environments in this manner. So We expected high values for presence and immersion, low values for experience, and higher values for behavioral attention. Here we can see the distribution of responses relative to variables of experience and presence and immersion. Besides poll results, we discussed with each user about their experience while watching the videos. Observing them also provided some interesting information, as our poll showed a number of users experienced high levels of nausea and could not watch the videos until the end. However, others had no problems going through all 3 sets of videos. While observing the users who were watching option 2 and option 3, we noticed that they were shaking and wavering a bit, and what is even more interesting is a report of 2 users who said that they could nullify the movement of the camera by walking in place. And so many users found the turning of the camera to be troubling, especially if they were turning their head in the other way from the camera. And there was a whole group of users who felt no discomfort watching the videos. They could look around and explore even when the camera was moving and turning. It is also interesting to point out that most of the users that reported nausea still went on and watched option 2, which is the set of the videos where we started introducing movement. So, to conclude, we designed a UX evaluation study to evaluate immersion, motion sickness, and user experience in 360 videos with moving cameras. Our UX evaluation results showed that the increase of movement increases side effects and decreases immersion, and that minimizing side effects enhances presence and immersion. So in the future, the experiment confirmed that camera movement produced unwanted side effects, decreased significantly the quality of user experience for all participants. In the future, evaluation should offer videos in random order and should include larger numbers of participants to provide a more strict statistical analysis of the results. And Bojan also had...
I'll just add for the end, even after we finished this study with the users, I had the opportunity to talk a bit with different programmers and people more involved in algorithms, and they suggested developing an algorithm which would nullify effect of turning camera, so to have a countermeasure on while the camera is actually turning, the countermeasure algorithm will turn the view field back, so user will not experience turning of the camera. It will always remain static, while he will still be able, or she, to decide where and what to watch. So this is something also to consider for the future shootings. Thank you.
Okay, that's all.
Thank you for the nice talk, but I mean you should explain why there is some museum for some tunnel.
Excuse me?
Why this is interesting? Everybody is using the word interesting as if we understood it. But what is interesting in the Sarajevo tunnel?
Well, it was the tunnel which saved many citizens of Sarajevo during the siege of 1992 until 1995, and we wanted to use this opportunity to replicate a traditional visit to the museum where you could follow the curator but also look around and watch what's happening around you.
Okay.
But yeah, the tunnel is a very important part of our history, so we wanted to also have a practical use of the application that we made.
Imagine the current war, 1 million refugees. Imagine in Sarajevo under siege, 11,000 killed people, and 3 million of refugees without, so to say, no public support from European Union. That's the difference. And the tunnel was an excellent trick. How go under the airport? The airport belonged to European Union, and people were prohibited to escape from this city. And that's why there is the museum. And that's why it is valuable to test there this novel technology. So that was just clarifying what means the interesting. And now, what is the scientific contribution of this? We have from Andrew Glasner that we have 5 depths of immersion. From just curiosity, they are singing some birds, to very moving experience, and this is something which can be somehow measured, but there is one method, quantitative questionnaires. Everybody is tired from questionnaires, and there are fixed questions, which is stupid. There is the qualitative method, where their experts can ask new questions. A virtual museum offers the 3rd measure of quality, the factor of engagement, the measure of how people, and you are on the way, that your there is exactly 21 interactions between users and avatars in virtual reality, 21. And your 21 users somehow selected what is interesting for them and how they spend their time. So this is, I guess, the way what to measure and how to measure. And so what is your sortiment of evaluation? I am again repeating in this session the question, how we measure the quality. How you will measure in the future the quality, continuing in your research line and confronting it with some other approach. That's the question.
Okay. Well, I mean, for starters, for this evaluation, a lot of different things could be done. Like you said, like a larger number of participants. We also didn't take into account, for example, if users were standing or sitting while watching these videos. This could also be another thing to test with users. Yeah.
Okay. 3 minutes for other questions.
Is it a possibility to see the 360 video here? Do you have
Actually, we do have a VR headset with us, and for the Saturday we have a planned workshop on cultural heritage and digital narration in VR headset, which will take for about 3 hours, and part of that workshop is designed for actually users to try different applications. So this being one of them, yes, you can try, because now we don't have enough time in these 15 minutes actually to show the real application. We can do that on Saturday.
Your work kind of reminded me of an application for Oculus where there is like a capture of Anna Frank house. You maybe know about it, where the user can actually walk around the house, and it also sounds sort of a virtual museum. So I was interested if you're also maybe planning in the future to somehow capture a 3D model of the panel using some photogrammetry or some other scanning process, and then maybe render this, and it maybe may have some advantages for you, because then in the virtual scene you can like simulate the various camera movements without actually capturing them using the camera, or maybe just like your experience in comparison with using the 360 camera to capture versus having a 3D model.
Well, yes, that's actually the work of DJ Bass, so...
I will answer for that one. We actually have an application of VR tunnel where you can walk through the 3D model tunnel. It lasts for like 4 minutes. The full walk, real walk, was like 12 minutes long in a perfect condition, so we could say even 20-25 minutes. But in ours it's 4 minutes, and you need to crouch all the time, move with your hands and things like that to feel the problem of actually passing the tunnel. And your question is good. Yes, it could help us overcome some of the problems with the camera, but our wish here was to actually test with the video, which has the limitations of not being a 3D model and how users can enjoy 360 movies in the future. So how can we make them active? How can we move the camera and not cause nausea in our users watching actually videos and not walking through the 3D models? Because you can manipulate how you walk around 3D model, you can stop, and here you cannot do that. So that was the difference why we chose videos.
Okay, let's thank. The next talk will be given by Michaela from Vienna. Michaela Tuscher comes from Far East Research Center, which is a spin-off of Technical University of Vienna, and VAR at the beginning means virtual reality, and risk in old Latin means the power. Power risk. The Austrian explanation is different, but you have listened to a special Austrian pronunciation of Czech. Please listen to your feedback by ears. Sometimes you smile, sometimes you say aha, and sometimes you say ah when something is beautiful. And in Austrian Academy there is a composition of these three feedbacks. It is for the first time this Czech Wimmer used this in his sharing. Michaela, the floor is yours.
Thank you. Hi, I'm Michaela, and I wrote a state-of-the-art report about processing speed and comprehensibility of visualizations and texts. So nowadays we come across visualizations multiple times a day. We see them everywhere, in newspapers, on websites. So it would be interesting to know how good they really are, especially in comparison to texts. So basically, we have two important questions here. The first one is, are visualizations or texts processed faster? And the second one is, which one is better comprehensible? So I tried to find answers for the questions, and I googled it. What is processed faster? And the first result I got is underlined in red here, and I read it for you because I think it's too small. Visuals are processed in the brain at 60,000 times the speed of text. And at first I was really happy and I thought, yeah, I already found an answer, but then I thought, okay, wait, 60,000 times? Isn't that a bit much? And also, what's the source for this? So I tried to find a source, and well, I found 6.5 million results that cited this sentence, and most of them were some marketing websites that try to tell you how good visualizations are and that you should use them everywhere. And the sources, they link to each other or to more or less scientific papers, and when I looked into the papers, I didn't find anything about processing speed. So there are even websites dedicated to find the source, but it seems like until now, no one was able to do so. So, are there any studies comparing visualizations and texts? So for processing speed, the answer is no, not really. And for comprehensibility, it is yes, but. And let's see what this means. So for processing speed, we have studies about recognizing targets in photos. This was done by Potter et al. The participants were shown a stream of 6 or 12 pictures, and they were given a target name either before or after watching the stream. For example, flowers. And then they had to say if there was a picture with flowers in the stream. And if there was, they had to identify the right one out of 2 pictures with flowers. And they were able to do this even if every photo was only shown for 30 milliseconds. Then we have a study about recognizing words by Hauck et al. It was very similar because the participants had to say if a word was an actual English noun or an invented word. And every word was only shown for 100 milliseconds. Then we have a study about reading speed by Dyson and Hazelgrove. They found out that the average normal reading speed is 4.06 words per second, and the average fast reading speed is 7.66 words per second, so nearly twice as much. So as you can see, until now we didn't have any studies that directly compare processing times of visualizations and texts. But what we have is one article by Dunn. He took the results from different studies, for example Potter and Hauck, and he estimated the time to process an image to be between 13 and 150 milliseconds, and the time to process a sentence of 25 words to be between 3.75 and 7.5 seconds. So he estimated that visuals are processed 600 to 600 times faster, and that's already a big difference to 60,000 times. So what about comprehensibility? Here we have studies directly comparing visualizations and texts, but we only have 4. The first 2 are text versus infographics. Infographics are a graphic type that contain graphical parts as well as textual parts. The first one was by Chibana et al. The participants either got a text or an infographic, and then they had to answer questions about it. However, they found no significant differences in comprehensibility, no matter if they had a text or an infographic. Then we have a study by Petrova and Rika-Kainen. Also, the participants either got texts or infographic versions, and then they had to answer questions about specific parts of the texts or infographics, and also about the general understanding. They found out that the specific questions were answered more correctly when they had infographics, but the general understanding was better when the people had texts. Next is McCrudden et al. They did a study with text and causal diagrams. And you can see the causal diagram, it's the top image here, or the only image at the moment. Causal diagrams describe cause and effect relationships with boxes and arrows. So the participants either got a text or this causal diagram, and they had to answer comprehension questions. Again, there were no significant differences in comprehensibility, but the causal sequences were better understood if the people had diagrams. Last but not least, we have a study by Branch and Roy with text versus flow diagrams. And you can see the flow diagram here. They also had different studying times, either 10 or 20 minutes to study either the text or the diagram, and then the participants had to answer questions. So they found out that it depended on the studying time which one was better. For a studying time of 10 minutes, the people with the diagram performed better, and for a studying time with 20 minutes, the people with texts performed better. Yeah, then there were many more studies comparing texts to text with additional visualizations. But in this case, it's hard to say what the effects of only text or only visualization would be. However, most of them said that visualizations had positive effects. So I want to show you some that had some different results. The first one is by Behrens and van Lieshout, and you can see it on the right. They did a study with elementary school children, and they had to answer math text questions. And the questions came with one of 4 different types of visualization. Either a bare visualization, which was only the equation to the text question, or a useless decorative illustration. Then they had helpful visualizations that illustrated what was happening in the text question, and then they had essential ones that added information to the text question. So they contained information that wasn't in the text question, and the people had to understand both to be able to answer the question. They found out that the bare ones were the easiest to solve, but if you already have the equation, there's not much more to solve. Useless were indeed useless because the participants spent time looking at the visualization, and it was diverting the attention away from the important thing, which would have been the text question. And the essential one was the hardest one to solve, because the children had to integrate information from text and visualization, and they found out that this is hard for younger children. Similar results were found by Schmotz et al. They had a study with visualizations and texts. The visualizations were, for example, such diagrams, and as texts they had image captions. And the diagram contained information that wasn't written in the text, and the caption contained information that wasn't in the diagram. So again, the people had to understand both. And they found out that, especially for poor learners, this was a hard task. So the last 2 studies. The first one was by Lenzen et al. And because before I told you about useless decorative illustrations, I want to show you a study that found positive effects of decorative illustrations. So they had a text about shadows, and it was accompanied either by a decorative illustration or a diagram or both. So they found out that if the people had a diagram, their interest was increased, and if they had a decorative illustration, it increased the alertness and calmness and the mood. And if they had both, the learning performance was increased. So the last study is by Pan and Pan, and it was with English learners. They had to translate the text from English into their native language, and it was about a traffic accident. And one group only got the text, and the other one got 3 pictures that explained what was happening in the accident. And the participants said that the pictures were helpful to understand in general what the text was about, but also certain words they didn't know. So, to conclude, what can we say about processing time? Well, photos are processed faster than texts, but not 60,000 times faster. And for comprehensibility, we can say if we only have text or only visualizations, both seem to be equally good. However, if we add a visualization to a text, it increases comprehension in most cases. But you should be careful with decorative images, because on the one hand, they can increase the mood, learning performance, and alertness, but they can also divert the attention away from the important things. Also, problems for young children and poor learners were found. So, what about our questions from the beginning? Well, we didn't find any satisfying answers, because for processing time, well, we didn't have any studies that compared processing speed of texts to processing speed of visualizations. And for comprehensibility, we only had 4 studies, and they had conflictive or inconclusive results. So more studies would be needed that directly compare visualizations and texts, but also pay a bit attention to the content, because it would be interesting to know if there are things that are understood better with the text or a visualization, for example. This concludes my presentation, and thank you.
Did you come across any study that would compare text and visualizations for specifically scientific audience? Like, we write papers every day, so what can we make better for our readers to understand our papers?
Yeah, I mean, most were with school children also, so yeah.
Unfortunately not.
No.
So how would you go about designing such a study that answers your question?
Actually, that's what I'm doing for my master thesis.
Good.
So,
Tell us.
yeah, so we looked for different visualizations, like bar charts and maps, and so not one specific type of visualization. So we have different ones, and then we have texts containing the same information, and then we will show them to participants, and yeah, we will ask them questions, and then we will see. And yeah, the time is measured also.
Martin. I was just curious. Have you considered using detection of facial expressions? Because in some publications, the facial recognition ability is obviously way faster for humans than other recognition abilities. Have you considered that option as well?
No, not until now. Okay. Yeah.
I just wanted to add to the previous question, to your master thesis. Did you choose like specific topic? Because I think, as you said, that it differs when you choose, like, for example, maps. I think when you give directions, it's like easier to just see it, like, go to the right here. So have you chosen like specific topic or at least like field?
No, we have all kinds of visualizations with different topics, and yeah.
And
so,
for example, what sorts?
Well, for the map, for example, about, well, different numbers for a country and different states of a country, different numbers for those states. For example, population or
It will be maybe interesting to utilize eye tracking as well, to see where the participants look at your visualization and what is most important for them. Maybe it will be interesting to also like capture this.
yeah.
So have you thought about it or?
Well, there were some eye tracking studies in this state-of-the-art report, and for example, for infographics, they reported that the people looked at the texts of the graphics and not so much at the graphical parts. So, yeah, actually we didn't want to include eye tracking. But, yeah.
Why? Like, why didn't you want to include that?
Oh, I don't know. I mean, we just said we would stop the time, and yeah.
Michaela, my question is not really a question. It is very challenging task, and I am looking forward to the results of your master thesis. And we have time for one more question.
Next year, Czech, you can present the results.
Okay.
maybe in this research, was there some possibility to measure processing time by more medical ways, like yes, exactly.
Yeah, I think that's what Potter did for their study too. Or I also have another study which was similar to Potter, and I think they did this. Yeah.
Brain-computer interface. Yeah. Okay. Let's thank Michaela. Thank you very much. Next paper you will discover in today's journal version of proceedings. The talk will be given by Michaela from Bratislava, and it is published as a poster, so we have, so to say, 7 to 10 minutes for this talk, and it will be presented by two speakers. Michaela Gubovská and Jakub Hajdu from Slovak Technical University. Please.
Hello? Is it on?
I've turned it off.
Oh, okay.
The oldest student.
Okay. Hello, my name is Michaela. I'm from the Slovak Technical University, to be more specific, from the Faculty of Informatics and Information Technologies. And we came here to present to you the results of our study on the impact of university education on human visual attention. So the reason we decided to study the impact of education on human visual attention is that there's currently no research on this topic. And as well, there's no data sets available that we could use to determine whether education plays a role in visual attention of people. So we basically analyzed existing research on other top-down aspects of visual attention, such as age or disease. And they all found that these aspects affect visual attention, so therefore we presume that education as another top-down aspect will affect human visual attention. So we proposed an eye-tracking study. We used the Cofee Pro TX300 table-mounted eye tracker to collect data about the visual attention of our participants. To be more precise, we had 20 technical and 20 non-technical university students, and our aim was to compare these students with different education backgrounds. Therefore, we decided to basically discriminate non-technical students so that technical students would be in favor, because we created 3 modules in our eye tracking study which contains different visual stimuli from the area of study of technical students, so that we could be able to analyze the possible differences. The 3 modules were designed in a way that 2 were for free viewing tasks and 1 was for a visual search task. Here are some examples. I hope you can see them. So here we can see examples for the first module, which was for free viewing. Here we can see some natural images of different technologies, and then the second picture shows technical images such as diagrams or graphs. The second module contained visual search tasks, and the participants were asked to find the specific value in the graph to answer our question. The graphs or the data visualizations were divided into 2 groups of more easier tasks, which contained more common graphs like a bar graph or a table, and more like harder tasks, which contained visualizations which were less common in media. So, for example, a stacked bar chart or a more complex line chart. The third module contained 2 tasks in a web browser, and the participants were asked to find the answer to our question again, and this was therefore a visual search task again.
Okay, I will continue. Hello, my name is Jakub. collected data from 20 technical students and 20 non-technical students, to be more precise, university students of humanities. And we compiled a dataset containing the original stimuli. We also included raw fixation data from the eye tracking software. We generated fixation maps and also exported video recordings with the participants' gaze points overlaid over the top. And then we set out to analyze the collected data and defined a couple of null hypotheses against which we tried to use statistical t-tests, and we found some statistically significant differences. For example, the first difference that we found was that the education background has an impact on the amount of collective visual information during free viewing images. The two graphs shown in this slide, they represent the first one, the average number, the average duration of fixation between the two groups. We found that there's significantly less time needed in a fixation in technical students, and at the same time in these previewing images technical students had significantly more number of more fixations over the same stimulus. We also tried to see whether there's a difference in overall task completion time in the second module where there was a visual search task. But we found out that there's no significant difference in the overall task completion time. However, we found out that technical students managed to identify the target firstly more quickly. And the third major difference that we found was that education background has an impact on the number of fixation during visual search tasks. We found out that technical students had significantly fewer fixations in the same task, and at the same time the proportion of fixations in the target area out of all fixations over the stimulus was higher in tech students. We can also look at these differences in a visual way in heat maps, for example. At the top we see a comparison of a free viewing stimulus. We can see that tech students tended to explore the image as a whole a lot more, as opposed to the second example below. That was a visual search task stimulus, and we can see that tech students tended to ignore irrelevant parts, I would say, of the image and would go directly to searching for the answer. Okay, so that's all for our speech.
Now we have very short time for discussion. As you did a shorter presentation, it should be somehow proportional. Please, Martin.
Have you considered doing a general sort of comparison with the same dataset? For example, something that somebody uses all the time, not just specific to the education background, because the diagrams are very specific to technical students, obviously, so they're trained for that, unlike humanities students.
Yes, of course, it's also possible to design a study also in a more general way, and also like comparing exactly the opposite, so favoring humanities, for example. But our specific study favors the technical students.
So I have a question. What exactly were technical students? It's kind of a broad definition, technical students.
The technical group was from our faculty.
So it was like all computer scientists?
Yes.
And the images were specifically by computer
Well, some
general technical visualizations.
I would say more general. Some of them may be specific to IT, but yeah, we also included some more common visualization types like pie charts, for example.
Okay. Applause for you. Maybe you noticed that we have a gender balanced session, and the next session will be, so to say, provide your pixels. We will arrange for a group photo here, and after that there will be a possibility for the Molpir tour. Molpir is the hill over there, the next, where there is some disaster changed into benefit. The original village there was killed out completely, but this helped to protect all the excavation, the valuable archaeological things. Some parts of that are the many arrows which were used for decreasing the number of individuals, and the rest was like in Pompeii, the nice image about how the iron was there produced and how the other valuable things were preserved. And I noticed already to Michi, do you know why the excavations are under earth? Because of worms, and this was proved by Charles Darwin. The worms